again, procedural assemblies, where we are now. Your tutor today is Alejandra Rojas. She's associate at Design Morphine and a founder by her company, which is dealing a lot with parametric mixing, kind of parametric and computational methods with ceramic and clay, I guess, pottery and other household items. Really great stuff. I own a few myself. Yeah, I'll hand it over to Alejandra.
Great, thank you, Mike.
Let me stop. There you go.
So I'll take over. I'll start sharing my screen. And hello, everybody. What we're going to do is that I'm going to jump directly into a quick presentation that I have set up for you guys, just to like give a little bit of background in terms of how is it that we're understanding the unit, and then understanding how is it that it starts clustering together. So we have a lot of like really exciting material. I'm hoping that we're able to like cover everything, and we'll also have a few breaks in terms of like doing Q&A. So don't worry, because all the questions will be answered. So pretty much the workflow that we're going to look at today is examining how a unit can aggregate to create a cluster by creating different connection rules. So we're going to like spend quite a bit identifying where exactly is that the unit can start connecting to another unit similar to itself, and a kind of like different units as well, and how the rules that we're setting in terms of like those connections really start creating a very diverse kind of like assemblies. So we're going to start looking at very quickly at a series of like examples, just so that you guys, you know, can start getting into like mindset of like a little bit of like the background of where this is coming from. And then we're going to start by looking at the units, since many architects have actually used the unit as a testing ground for new living approaches. So we're going to start looking by a few examples, starting by Futuro Home. That was kind of like this unit that was meant to be super light enough for a helicopter to like airlift it to like many different locations. This unit was comprised of like a 16-part system that could be dismantled and then assembled back together in 2 days. So it was a pretty cool system that at some point it was thought also to be a hotel. Then we, as you guys, or some of you guys may know, the Embryological House by Greg Ling, that was designed to move between different locations as well. And it's very adaptable for use as either as a standalone house and also as part of like an urban system. Then what we're going to jump to at a series of like quick studies that Buckminster Fuller did for like different housing prototypes. The very interesting thing about what Buckminster Fuller did is that he took it a little bit of like a step further in terms of like how he was thinking of the actual geometry of the single unit, so that then he could start thinking about how the singular could start evolving into a collective. So in the Dymaxion for the tower, that is actually a little bit of like a continuation from the previous unit, the Dymaxion house that we see. It starts thinking about how like a hexagonal floor plan can start aggregating into a tower that is pretty much organized around a central mass that is not only structural, but it also holds all the services. So then we go a little bit further in time in terms of like understanding Unité de Habitation as kind of like a precursor to like the plug-in system that was constructed from 2 components. So like a very big lattice frame that served as a mega structure where the apartments were acting as autonomous units that were really slotted into the voids of the frame. So it became kind of like a playful system that opened up different like views into like how we could start thinking about the different units and how we could start aggregating them. So in terms of like cluster examples, I just wanted to show you guys a few that I think are very interesting because of like the different geometries that they hold. So we have the Ivory sur Seine, and I'm sorry for my bad pronunciation, but it's a social housing that is comprised of 40 units. And actually within the 40 units, there are 27 that are different from one another. And the cool thing with most of like these examples that we're going to start looking at is that they were thought to be very simple assemblies. So in this case, for instance, we're looking at precast concrete panels that were assembled on site, and the units are connected through horizontal walkways. So it's very interesting if you guys want to dive into like a little bit further into studying like this housing, like how is it that you're actually circulating through them, you know, where is structure, where is like the mechanical. So all of those become a little bit of like kit of parts that create a more complex aggregation system. So then at the lower image, we see Glenn Small, the architect, kind of like imagining the green machine. So in this case, it's a little bit different because here what he envisioned is, again, a modular system that consisted of like trailers, Airstream line trailers that were actually plugged into this kind of like space frame called that we can call like a mega structure. So it had a total of 24 units that they were again connected through the horizontal walkways. And then we go into kind of like archigram that I particularly am very fond of, the walking city. As you may or may not know, it was thought as, you know, a massive kind of like intelligent building or robots, you know, that were pretty much housing or containing a bunch of living pods that could pretty much roam around the city. But as much as the pods were kind of like independent, the interesting thing was the idea that they could potentially connect back or plug into like way stations where people could exchange resources or goods or anything. So as much as we are talking about the individual units, we are also coming to the understanding of like how the units actually get assembled to form the collective. So in the image at the bottom, we see the Oriental Masonic Gardens by Paul Rudolph. So in this case, we're looking at around 148 units that were grouped into kind of like clusters of 4 so that they could like share a utility core. So each prefabricated unit is made entirely from wood. And a firewall that is constructed on site prior to actually started to insert the units. So again, these are very interesting projects if you guys want to dive a little bit deeper. Another one of my 2 favorites are, again, excuse my pronunciation, that's that Arachnids, that was designed as an actual kit of parts. And again, the fabrication was meant to be a plug-in system into a steel superstructure. So we're going to see a lot of like this idea of, again, the units coming together to create the aggregation, but also the idea that once you create a flexible system like this, you can constantly keep adding or removing units. And this was a little bit of like how the Nagakin capsule tower, as part of like the metabolism movement in Japan, was kind of like conceived of in terms of like multiple capsules that could be modified to create larger spaces in the system. So a little bit of like, not so much a fun fact, but when the tower was actually envisioned, the architect meant for the capsules to actually be replaced every 20 years. So that's why now the tower is, kind of like falling apart, because it never got to the point where it was actually replaced. So one of the examples that we're going to like see a little bit in detail is a Ramad housing. It's roughly comprised of like 720 units that are varying in size and number of rooms. So each of the housing blocks is organized around 5 interconnected external courts that are linked together by the ground level walkways. So in the image, you guys can start seeing a little bit of like how as a master plan, the clusters also start aggregating together to form kind of like a housing complex. So here we can see that the architect was actually kind of like inspired by a lot of like natural systems like crystals, bee swarms, and honeycombs. So he really wanted to kind of like work with the structural and organizational properties of like a dodecahedron, so a 12-sided volume that he could like start aggregating to create the facade and the units. And this is a very like interesting system, because then he also incorporated within his cluster design the actual core, and then how this then aggregations could be replicated again as a kind of like urban setup. So then we go to like Habitat 67, which is a complex in Montreal. So this was another system that kind of like emerged from like a bottom-up design approach, meaning that rather than the architect controlling the formal aspect of the design, he actually created a series of like rules as to like how his units would start kind of like connecting one another, and then the system just grew from those rules and those connections. So this was really inspired from like some of like the earlier houses that we saw from Buckminster Fuller, and the bigger idea of how like the single unit could really start informing how the collective works. So in here, these are a series of like case study projects done by some students, where I wanted to like show you guys how having even like a simple kind of like band block, you can start organizing it and creating different unit types that in the larger schemes starts creating really interesting aggregation clusters. And then we can start incorporating the cores and the walkways to it. So then I'm going to like go a little bit faster through the next examples, but Kengo Kuma and Associates are constantly revisiting the idea again of like how you can use, in this case, wood joint connections to create larger assembly systems. So they have a series of like very interesting pavilion designs and actually interior designs like Starbucks. I think, I don't remember exactly what city they did it at. But it's again based on this idea of like understanding a very simple connection, and then how do you replicate it to start creating like a cluster or like a larger design. So in the bar led, there's also a lot of like research led, this case by Jules Redson, in terms of like how, again, you can start working with this idea of like the unit and start aggregating to create different shapes of forms. In this case, a chair. Then the interesting thing about this project is that the actual robotic arm is the one that is making the decisions, or is helping within the process of like how is it that the different pieces start coming together. And then one of the final projects that I wanted to like quickly share is by Jose Sanchez and his research group at USC with his students, where they are exploring the idea of like repetition and mass production, and they are focusing on creating a smart brick that can aggregate and connect in different ways so that you can start having more, a little bit more of like customization. And a lot of like these projects, you guys can find that in the discrete series of like AD magazines. So this is pretty much like a really great resource. And then also Adaptive Ecologies by AA. So they give a little bit of like the background of where some of like this kind of like trends in architecture is starting to like to come about. So now I'm going to stop sharing my screen for a sec, and then let's dive in right into like Rhino. So what I want to do is I'm going to stop sharing my video so that I can make the screen a little bit larger. And then what I want to ask everybody is to please open exercise number 1. So you guys should have received this yesterday. So if everybody can please open it so that we can start. So what I'm going to do is I'm going to use the Rhino file, but we're going to start from scratch. You guys can reference the Grasshopper file that we sent. This is meant so that in any case you guys feel like you're stuck or something, you can like reference back to here. But ideally, it would be great if you guys can start from scratch. So that I find that you guys learned more when you're trying to follow rather than just, you know, looking at the at what I'm telling you guys. So normally this is the part where I ask somebody to tell me if they can see the screen and everything is working correctly.
I see the screen.
Okay, thank you. Just to make sure that we are on route. So this is something that you guys don't have to do, that I'm going to like put up here. These are called bifocals. So this is just going to allow you guys to see the actual name of the component that I'm going to place on the Grasshopper canvas to start creating the definition. So again, you guys don't have, you probably don't even have this, so don't worry about it. It's really just helping me set up the definition so that you guys can see the name of the component, just in case you guys feel like you're getting behind or need to like reference something. So exercise number 1 should have a very simple geometry that is actually in the geometry layer. It should have another layer that is called center. So you guys will see that if you unpreview it, those would be the points that we have set up, and I'll explain why in a minute. And then we have some red lines in the direction layer that again, you guys can see on the Rhino viewport. So what we're going to do is that we should all now have our Wasp plugin working. So what we're going to do right now is use its unit to create a very simple aggregation. So in able to do that, we're going to like start by setting up like the very minimum components that we need to create the aggregation. So for that, what we're going to do is we're going to go to Wasp parts. So Wasp is divided into elements, parts, rules, aggregation. There's some like disco for virtual reality that we're not going to get to. And then we're going to try, but I don't know if we'll have time to like get into experimental. So the minimum parts that we're going to like look at is the elements, the parts, the rules, and the aggregation. So the first thing that we're going to go is we're going to get into the part, and then we're going to get the basic part. So this part is what is going to help us actually tell Wasp that we want to start aggregating this unit. And in order to do that, we're going to require a few inputs. So the first input that we're going to require is a geometry. So the geometry is something that we're going to double click in our Grasshopper canvas, and we're going to type geometry. And then we're going to click on this, and then we should have a component that pretty much doesn't have any inputs or outputs, because it's going to serve us as a link to get geometry from Rhino. So what I'm going to do is select this geometry, then right click it, and then I'm going to go to set one geometry. So I'm going to click in this one, and then I'm going to go to Rhino, and then I'm going to click that geometry. So how do I know that it works? Because now the component is not turned orange like the one that is with Wasp, but it's actually turned into like a light gray. And now if I preview my layer of geometry in Rhino, we can see that we have the same geometry that is shaded in red. So now we know that we have our geometry in Grasshopper. So what we can do is that we are going to connect this geometry into the output of the geometry part. So this is what, again, is going to start helping us set up the unit. So the next thing that we're going to see that we need is a name. So we need to figure out how to name this unit. So what I'm going to go here is you guys can do // as a shortcut for panel. And then we're going to write here unit. And then I'm going to click where it says panel. The other way for you guys to get the panel is if you go to the very first tab that is called parameters or params, you can get here the panel. And then you can double click, delete that information, and just type in unit. So it's the same thing. So the next thing that we need as part of like setting up our kind of like unit for Wasp, we need a connection. So this is a very important part of it, because this is how we're telling our system, the system that we're starting to create, how is it that we want to start aggregating this unit. So what I'm going to do first is I'm going to go back to Wasp, and within elements, I'm going to say I want a connection from direction. Why do I want this one? Because this is going to help me or help the system know what faces I want to connect which faces. So this is why we have already set up a few points in the geometry, so that we can start telling our system how we want to connect things. So in this component, we can see that it's also asking us for a geometry. So this is the same geometry that we're going to connect over here. And then the next thing that we see is that it's asking us for a center, and it's also asking us for this up means that it's asking us for a direction. So what we're going to do here is we're going to bring some points. So similar to like how we reference the geometry of the unit, we're also going to reference from Rhino those points that we see on the screen. And then the next thing that we're going to reference are the curves that I have in red right now, so that those can serve as a direction of like how my aggregation is working. So now I have those two. What I'm going to do is I'm going to right click, and then I'm going to say set multiple points. So then I'm going to go to Rhino, and then I'm going to just set 2 points right now. Okay, so we're going to set the ones that are on the side faces. So we're going to set 1 and then 2. And then once I'm done, what I'm going to do is just hit enter. But then we see a couple of like X's over the points in Rhino. So in order to visualize which order I set them up in, what I'm going to get is a point list. So this is kind of like a preview that what it's going to do is going to number the order in which I inputted my points. So we can see here that it's actually huge, but it's okay. And I can control it with this slider. So to get this slider, what you guys can do is again, double click on the canvas and just set up a number. It can be whatever you guys want. I would make it like 1.5 or 1, not too big. But the idea here is that I can visualize now the order in which I set those points. And this is very important because we need to set up the curves in the exact same order that we inputted the points. Because if not, this connection component doesn't know or can't figure out where you're connecting and how you want to connect it. So we need to make sure that both the point and the curve are in the same phase. So what I'm going to do here is the same. I'm going to go to set multiple curves, and then I'm going to select 0 first, and then 1, and then hit enter. So now I should have my curve and then my center points. So now I'm going to connect the center, and then I'm going to connect the curve. So the moment that I do that, the component starts running, meaning that the component is going to map a series of like planes in each of the faces that I want to connect them to. So this is how we know that the system is actually working. So now I have like all the information here in the output in terms of like the connection that I need to plug into my part. So now this is how I'm setting up the unit. So I have like the parts, the basic Wasp part that I got from here, so basic part. And then this component part is asking me for the connection that I'm getting from the elements over here. So connection from direction. And this connection is needing the points and the curves that need to be taken from the same face. And it's generating a series of planes. So that's how we know it's working. So one thing that we can quickly do here is go to the center of this component, middle mouse click, and then on preview. It's so that it doesn't become super messy. So now what we're going to do is we're going to keep going with our system. So now that we have the unit, what we need to actually do is create the aggregation. So for the aggregation, where we're going to go is where it says aggregation, and then we're going to go to stochastic aggregation. So we're going to place it right here. So the stochastic aggregation is where the elements, where we're going to like pretty much plug in our units, and we're going to plug in a series of like rules that are telling how is it that we want to start connecting our units so that it can generate our aggregation. So what we can see from like these sets of inputs is that we're going to need quite a few things. So the very first thing that we're going to need is to actually connect the parts. So what I'm going to come here, and then I'm going to connect the part right there. The next thing that is asking us is for previous aggregated parts or locations. We're going to deal with this in the next following exercises, so we're going to leave that aside for a second now. The next thing that is asking us is the number of parts that we actually want to start aggregating. So I'm working from a desktop computer, so it has a little bit more power. So you guys pretty much know the power of your computer. So I would tell you guys to like please start with a small number. Don't go to like 2000 right away. Let's start always small so that you guys are not crashing your computers, and then we can start slowly kind of like increasing the numbers. So I'm going to start with 120, which is a great slider because it allows me to go all the way to 1000. But I'm going to set it at 100 or 100 just to like make sure that nothing happens for right now. So then the next thing that is asking us to do is for a set of rules. So what are the rules? The rules are a series of information that again tells the system as to like how you want to aggregate them. So what we're going to get is we're going to get the Wasp rule generator. So this is a great component because rather than us typing all the connections, it actually generates them for us. So in the next exercises, we're going to look at each of one of those rules. But for now, we just want to create a very simple system. So we're going to like map the parts right there, because this one is asking us for the parts. We're going to look at these different inputs in the next exercise, so don't worry, guys. And then what we're going to do is plug in this rule over here to our stochastic aggregation. So you guys are going to realize that once you connect the rules into the aggregation, the component, rather than being orange, it turns dark gray, which means that it's now working. So it's working, but we don't see anything. And that's because we actually need to do an extra step to be able to like visualize what we're getting from this. So we need to go to parts, and then we're going to go to Wasp get part geometry. So this is going to help us visualize what's happening. So once I plug it in, you guys will see that automatically we start seeing a lot of like units in Rhino. So here is where we can start adding or like increasing the amount with the slider. So what you guys will see is that this aggregation, what is given us is a very flat aggregation. So no matter how many units I start increasing, no matter what, it's always going to be a flat aggregation. So the reason for this is because the faces that we have set as part of like our aggregation unit, as you guys can see, are the side faces. So we haven't told the system that we want to start connecting top and bottom. So that's why we're staying right now only in the one level. So one quick thing that I want to show you guys before we start telling the system, let's make this a little bit more three-dimensional, is that we can actually use a custom preview so that we can visualize this a little bit better. So the custom preview is great because you can like change the color. So I can like type color swatch, and then by clicking on this color swatch, I can click any color and then connect it to it. So now rather than seeing kind of like a ghosted preview, I can start seeing more of the shaded preview that we're used to in Rhino. So again, let me go back to this and quickly reiterate. So we had our unit part set up. So then what we did was get the stochastic aggregation from aggregation. And then what we're doing is setting up or connecting our parts so that this aggregation knows what unit we want to aggregate. And then we're creating, or we're setting up the rules generator from the rules tab. That is the last one here, so that we can start telling or start generating, or in this case, auto-generating the connections that we want to do within this phase, within this unit. And then what we are doing is we are visualizing what the aggregation that we are creating through get part geometry, that we can get it also in parts, get part geometry. And then we're just visualizing this a little bit different. So this component was actually in preview, but then we go to the middle of the component, middle mouse click, and then we can unpreview it. Okay, so this is kind of like a very simple, very fast kind of like system with a minimum set of components from Wasp to create an aggregation. So now what we're going to do is actually include bottom and top so that we can start aggregating up and down. So what we are going to do is I'm going to unpreview this so that we can start a new one. So we're going to use a lot of like this component. So one of the things that I could do is we could copy paste this. So copy paste, and we're going to move it over here. So I hope that everybody's following. Okay, so for this, what we know is that our geometry is already set up, but to not get duplicates, I want to make sure that this entire definition is unpreviewed. Okay, so now we're working with here. So now in this case, what I want to do is I'm going to start referencing all the points. So for this, what I'm going to go again to my point, set multiple points, and then I'm going to go 0, 1, the same ones, and then I'm going to go top, bottom, and then I'm going to go to the back, and then I'm going to hit enter. So now I have more points into the system. So now everybody should have 5 points, and I say 5 because we start counting from 0. So in this case, 4 doesn't have, 4 I don't believe has a line right now. So maybe what I'm going to do is a couple of things. We can either draw the line or we can ignore that point for now. So sorry guys, I have to like go again because 4 doesn't have a line at the moment. So we're going to do it again. So 0, 1, up, down, and then hit enter. So now we should only see those points. And then we're going to go back to the curve, set multiple curves, and then I'm going to go 0, 1, 2, 2, and 3. So that should give me the setup. So the next thing that I'm going to do is start creating the same aggregation. So what I'm going to do is go to my aggregation and then do the same stochastic aggregation. So, and then I'm going to also bring again the rules generator so that we can see now what happens when we input a few more points into our system. So I'm going to connect the parts right here. I'm going to connect the part into the rules. I'm going to bring the rule in here. And then I'm going to start again with this system as 120. So then what we're going to do is bring the Wasp get part geometry, and then we are going to visualize what we're getting here. So what's happening here is that we're creating, or we're getting a little bit of a mess. So if you guys start seeing this aggregation, we are starting to like create a lot of a mess. And why is this happening? Because what we're doing is that now we're giving it 4 different connections. And what's happening is that the 4 different connections that we're giving it, it's pretty much connecting all between one another. So what we need to now start doing is controlling which connections we kind of like assign to one another. So for that, there are different ways in which we can do this. So first of all, I want to show you guys what's happening with this rule generator. So in this rule generator, what we're doing, or what's outputting, is that we have all of our connections, and this rule generator is telling connect everything to everything. So it's telling it to connect the 0 face, it's telling it to connect to the top connection, to the bottom connection, and to the other side connection. So that's why when we're looking at the global system, we're starting to like see that a lot of like this units are starting to like get rotated into like completely different directions. And this is why we need to start actually deciding or checking what is it that we want to connect between all the different, how is it that we want to start connecting all the different parts. So there are a couple of ways to do this. So we're going to start looking at a series of them. So the first one that I want to take a look at is, let's see, give me one sec. The first one that we're going to look at is the Wasp rule. So this Wasp rule is super handy because it allows us to specify what units do we want, and then what connection from that unit we want to connect to, again, which connection, which unit, and which connection. This will get a little bit simpler once we start setting this up. So what we want to do is we want to tell it that we want to connect our unit, that is called unit, within itself. And then what we want to start understanding is where are our connections. So here we can see that we have 4 connections. So what I want to tell it is that I only want to connect 0 to 1. So the way that I'm going to do that is that I'm going to create a panel, and then I'm going to type 0. So 0 is the name of that connection from the unit that I want to connect with 1. So now, instead of like having all the connections being connected to everything, I'm going to show you that now we just have the one simple rule, that we want 0 to connect to 1, and that's it. But we also want, and I'm going to copy paste this, I also want for 2 to connect to 3. So what I'm going to write here is 2 to connect to 3. So what we're doing here is that, again, rather than having everything connect to everything, we're kind of like specifying what is it that we want to connect with what. So now what I want to do is I want to plug in these 2 rules that I'm creating. So 0 connect to 1 and then 2 connect to 3. I want to be able to like plug it into like my rules right there. So in order to do that, I have two ways. So the way that I like to do this is by calling the merge component. So this merge component is going to take the information from this rule and the information from this other one, and then it's going to combine it into the one list. So what I'm going to do is that if I drag this wire over here and I plug it in, it's automatically going to unplug this rules generator. Okay, so again, if that one was connected there, what I can do is just plug that one into rules and it will disconnect my rules generator. Okay, so now what we can see is that we still have the chaos. And this is happening because we haven't reset this system. So the next thing that we need to do is double click on the canvas and type button. So this button is really great because it's going to allow us to reset the system, meaning that every time that I kind of like change any of these outputs that are related to the rules, that are related to the constraints that we're going to see later on, it needs to restart. So now when I restart it, what happens? So I create a full stack of the geometry, right? So now we can see that everything is stacking completely upwards. Why is this happening? So this is happening, right? So if we take a look at this, it's because we're telling 0 to connect to 1. So if you can like visualize, right, this geometry kind of like, right, mirrors on this side and then mirrors again because now 0 would be somewhere here, right? And then 1 would be here, so you would want to connect another one and so on. So we are always working in a closed loop. And then we're also telling it, you need to connect 3, right, to 2. So that's why we are seeing that it's constantly stacking up. So the point that I want to make here is that how by controlling the rules, we can really start completely altering the system. And again, we always need to start resetting it every time that we're changing the rules. So that's one kind of like different way to start, you know, controlling your rules. I want to go into another one that is actually I'm wondering, let me think what we could do here too is add a couple of more rules to this. So what I'm going to do is leave this as is. I'm going to copy paste it over here so that you guys can like reference back. And then what we're going to do is, I'm going to do this a little bit the long way so that it's just super clear. What we're going to do now is tell it that we can also do other connections. So not only connecting 0 to 1, but I also want to connect maybe 0 to 0. So what it's going to do is that it's going to force it to do something a little bit different. So now what I'm doing, I have copy paste this so that I can create another rule. And the cool thing about merge is that merge allows me to like pretty much input as many different examples as I want to. So now what I'm going to do is by zooming in, you guys can see this plus and minuses. So I just added one new one by saying plus. So this is going to allow me to create an extra plugin for the new rule that I just created. So now what I'm going to do is replace this one with the rules, reset my system, make sure that we preview it. And now what are we seeing? We're seeing something, right? slightly different. So what is happening now? What's happening is that now I'm forcing the unit to actually rotate because I'm telling, okay, so if this is 0, 0 can only, right? 0 also needs to connect to the same unit, right, at 0. So that means that rather than creating like a mirror setup, right, that was giving us that very close loop, now I'm forcing that geometry to rotate. So now it's starting to get us a different definition, right? So now if I start kind of like increasing the number with the sliders, we start seeing, right, how that aggregation is working. And then if I plug in the previous one and I reset it, right, it's very different. Why? Because now I'm adding a different rule that is creating a different type of connection between that same unit. So my point is here that we can really start creating so many different variations just from the one unit and really understanding what are the different connections, right? How is it that we can connect this unit? So let's do a couple of more and then we'll move on to the next exercise. I just want this to be super clear because this is going to be pretty much the base for absolutely everything that we do. So here, what I'm doing is kind of like creating different clusters of rules. So now what I want to do is let's also force it to go in the other direction. So in here, what I'm predicting is that we're not going to get that much result difference from the previous one, but we're going to start seeing how we can kind of like expand a little bit more the geometry. So rather than having 0, 0, 0, 1, now what I'm going to have is 1, 1 as well. So I'm forcing the geometry, right, to rotate along this side, but now I'm also going to force, oh, I just realized something. And you guys may hate me for this, but I love annotating. So now rather than forcing the geometry to just, you know, rotate this way, I can also force the geometry to start rotating the other way. So this is again going to start creating a slightly different aggregation. So again, what I'm going to do is plug in the system, make sure that all my connections are good, and then hit reset, make sure that I preview, and then I should see that it's starting to expand a little bit more, right? Great. So just by that, right, now it's not going just along one direction, but it's starting to aggregate along the sides a little bit further. So now, for example, if I wanted this aggregation to start maybe migrating downwards, another thing that I could do is I'm going to unpreview this. Oh, we didn't connect this guy. Sorry, guys. Give me 1 sec. So let's connect that guy. So maybe I was just seeing things. There you go. Now we can see that the aggregation is kind of like moving outwards a little bit more. So now what I want to do is rather than having the aggregation just go upwards, I want it to go downwards as well. So rather than copying this, what I'm going to do is I'm just going to copy the last rule, and then I'm going to flip this 2 around. So I'm going to say go from 3 to 2. So hopefully that should give me an aggregation that starts going both ways. So it's just not going upwards, but it's starting to like go downwards as well. So if we look into the side views, we can start seeing how it's starting to like grow both ways. Great. So a quick thing that we could that we could do just to like preview this is slightly different is that we could, and this is just a little bit for fun, we could create a dispatch. So I could like connect my list here. And what dispatch does is that it pretty much with a pattern, it tells some of the geometries to go to one list versus the other list. So we can just use its default pattern that is true, false. And what we can do here is just, you know, kind of like have one custom preview with one color and then have the other list with a slightly different color. And then this can just helps us visualize things a little bit so that it doesn't all look like the same color. So just to like quickly reiterate before we move into the next exercise, since we're doing good on time, the rule generator pretty much creates a set of like rules that takes all the connections and connects them one with another no matter what. So what's happening here is that we're having almost like zero control really as to like how, you know, the connections are creating like the different aggregations. So by using the Wasp rule, what we're doing is that we're really telling the aggregation exactly how is it that we want to start connecting our system. But then we can really start manipulating those connections so that we can like start creating completely different results. So we can like really start manipulating and controlling a little bit more of that aggregation. And then the last thing that I'm doing, just as a quick way to reiterate that as well, it's just that I'm using dispatch, which is another Grasshopper component that just allows me to use a very random list. Right now is true, false, meaning that one item will be displayed in this color and then the other item will be displayed in that other color, just so that we can create a little bit of like variation. So I hope that that's clear. I don't know if there are any super major questions before we move into the next part.
Hey, Alejandra, there's
Yeah.
just there's one question in the question box.
Okay.
I've answered a bunch that I think you necessarily don't need to answer, but there was one that I couldn't quite remember, which was, does WASP, like, is there a way to put a hierarchy to the WASP rules? Meaning, can some rules be more important than others?
Yes, yes. Actually, some rules can be more important than another, and it deals where exactly in the order that they are, but it also deals with this. So for example, you guys, that's an excellent question. You guys have seen that in this example, right? I'm taking some of like the side connections and I'm saying 0 with 0, 0 to 1, 1 with 1, and so on. So this starts to take a larger role than aggregating vertically, because now if you see at the list that this generates, this set of rules now has 3 against 2. So no matter how many times you reset this aggregation, you guys will notice that it has a tendency to go more horizontal than vertical, if that makes sense.
Right. So you're kind of like doubling up the rules when you want them
Exactly.
more important.
Exactly. So that's one way to control it.
Great. And then there was just one more, like, what is the criteria of dispatch to separate lists? I know right now you're just doing it by random kind of true and false pattern as a display thing. But, you know, from what I know, eventually when we start using multiple parts, you can kind of call those parts out separately, which they'll see later.
Exactly. So once right now we're just working with the one unit. So what happens is that really everything in the system is kind of like the one unit. So one thing that you could do, let's say, if you really want two units that look the same, but let's say have different openings, right? Or have different details. What you could do, that is something that we're going to see in the next few exercises, is that rather than just have the one unit, you could have two. So then when we are at the end of the aggregation, we could actually filter, right? We can actually filter out here the two different units based on the name, so that you guys can render it differently, or if it has like slightly different details and whatnot. So I hope that that makes sense.
And let's just ask one more before you continue. So is there a way to set seed values to avoid random assignment of elements? From what I know, it's random, but you can export like the results rule, like the result. I forget what it's called. I'm sure you know.
Sorry, can you? I guess I'm a little bit unclear on the question.
You know, like when you reset the, you know, it's always random. And they're asking, is there a way to set a seed value so that you can get the same result you had before? And I know there's a way to export.
So there's a way to export. So we'll see this as well. So within parts, within aggregation, what you guys have is save to file and then also load. So for example, if I were to like love, let's say this aggregation, what I could do is I could go into the aggregation, save to file, and then rather than saving, like, let's say this part out, what I could actually do is save this aggregation over here. So I could connect the aggregation, and then what I can do, and we'll look at it a little bit more in detail, but I could like set up a file path where I could indicate where is it that I want to save this. So I could like, you know, set a directory so I could save it to my desktop. And I think it's taking a minute. Sorry guys, it just froze a little bit.
Yeah, and just as a side note, I've actually spoken to him, the developer, and there is a version of Wasp in his GitHub, which we didn't use for this webinar because it's kind of experimental and work in progress, which I believe he told me does explore using seed values for the aggregations.
Yes, but I think the GitHub is still in beta, so I know that he's changing quite a few things.
Yeah, that's why we didn't use it.
Yeah. But definitely that's something that will be, I think, part of like the next update. But for now, one of the things that you can do is, you know, save the actual file. So you can like indicate the name here. So you can say, you know, aggregation, you know, 1. And then you can just, I believe it's a toggle. Let me check. So true to export. So you guys would have to like set up a Boolean toggle. So this just goes back and forth from true to false. So if it's true, what it outputs is a JSON file that you then are able to again go back into aggregation and then load it. So this is pretty great. Because it really allows you to like work with a different iteration so that you guys can pretty much keep track of the work that you guys are doing constantly, if that makes sense.
Marios in the chat informed me that it's actually version 4 of Wasp in the GitHub has seed values. So if anyone is interested to explore more experimental version of Wasp afterwards, definitely check out their GitHub.
Yeah.
So
yeah. No, sorry, go ahead.
Oh no, I was just gonna say I'll let you get back to your lessons here.
The other thing that I was going to say is that Andrea Rossi, the creator of Wasp, also started creating like a devlog series of like tutorials where he's actually, you know, kind of like going through the the updates that he's doing to Wasp. So if that's a really interesting set of like tutorials, if you guys want to also dive a little bit deeper in this and understand what he's now working on.
Yeah, they actually just posted the YouTube link in Patrish posted it in the chat. So
no,
if anyone is interested, go to the chat.
It's super interesting. He's like a really great, and I think he's taking Wasp into like a super interesting direction. He has a kind of like isn't Duckworth? I can't pronounce it very well, but he has a group chat. So a lot of like architects, developers are like constantly writing to him. So he's implementing all the different ideas. So I would also suggest you guys to like, log into that community because he's great at responding and like really using your feedback to keep improving the plugin. So it's pretty amazing. Okay, so what I'm going to do is I'm going to save this file. I'm going to move my annotation. Sorry, guys. I'm going to save this file, and then if we can all open, I'm going to save it as exercise 1 point, just in case you guys need it later. And then let's open exercise 2. So I'm going to stop sharing so that I can open the new file. So let's go to exercise 2. I'm loading the file, guys. Give me 1 second. And then we'll start in a minute. Okay, so I hope that everybody has now opened the file. I'm trying to partition this so that you guys can see everything. Okay, great. Sharing the screen again. Okay, guys, so in the second exercise, you guys should have a little bit of like the same setup right now in terms of we have placed for you guys the geometries, and the geometries are under the layer units in Rhino. So if I zoom in a little bit, you guys will see exactly the same thing. So the center points, then the direction, and then finally the geometry. So you guys also have access to the Grasshopper files that we're going to go over. Again, I would suggest everybody to like please follow along, and then use the files only as reference. So what we're going to do is I'm going to create a new file so that we can like start from scratch. And then what we're going to do is right now we're going to ignore the 2 units. We're going to start with a single unit. And again, we're going to start building up in terms of our like our aggregation. So bear with me. So the very first thing that we're going to do is double click on the canvas and we're going to get our geometry. I'm going to get my bifocals. You guys don't need to do this. This is so that you guys can see the little cloud thingy over here saying what is the name of that component. So I have my geometry. I'm going to get my basic parts. So I always kind of like to set up what I'm working towards. So I know that I'm going to need my basic part right there. I know that I'm also going to need my connection from direction. So these are the kind of like elements that I need to set up my unit. So the very first thing that I'm going to do is right click on my geometry and then I'm going to say set one geometry. So I'm going to click on the Rhino file. So now I should see the file that it turns green or red. So that means that it's now linked. So now I can turn off my layer geometry in Rhino. So now I can start connecting things. So I'm going to connect my geometry both to my parts component and also to my connection from direction component. So this one, what I'm going to call it is I'm going to call this connection Y. Why? Because it looks like a Y. But yeah, that's my silly joke. So now we can call it Y. And one thing that I would suggest though, maybe so that it makes it a little bit simpler later to write the rules, let's have it with capitals. Then the next thing that we need to do is actually, again, bring our points. So let's bring our points. We also need our curve. So what we're going to do is let's first just connect the front and the side. So meaning the front here and the back, not the side. So the front and the back. So what I'm going to do is I'm going to go to Grasshopper, right click where it says point, and then I'm going to do set multiple points. So I'm going to click first on the front and then on the back and then hit enter. So just in case, I'm going to bring my point list. So I can just double click, do point list, connect my points. And then for the size means for the size of the text that I'm displaying, I'm going to just make it slightly larger. So now I should have 0 and 1. So this is going to help me as a guide to again set 0 and then set 1. So now if I hit enter, now I should have them both running. So I should be able to connect this to up and then connect my points to center. So I know that my component is working now because I have my planes that are displaying. So great. So now what I want to do is similar to what we just did, set up our connection output into our part connection input. So we can again preview this. So I can go to the middle of the component and just say disable preview. So now I have, again, I'm setting up like the unit for this next aggregation. So what I'm going to do is I'm going to go to the aggregation tab, and then I'm going to do again stochastic aggregation. So we're going to be working with stochastic aggregation for quite a bit. Then we're going to look into the field driven aggregation. So don't worry, we're going to get there. It's just that this part takes a little bit longer just so that we can really understand how to set up the rules. So we know that now we need to connect our part into aggregation because we're telling it this is our unit. Let's connect it. Then the next thing that we're going to do is we're going to go into our rule generator just to see quickly what is it that we are outputting. And then I can connect this one to here. And what I'm going to do is, again, I always like to start with smaller numbers. And then you guys can start increasing. The next thing that I'm going to do is set up my button so that I can like reset this. And right now, as we know, nothing is displaying on the screen because what's happening is that we need to go to our parts tab and get our part geometry. So where it says parts out, that's how we connect it. So now what we can see is that we only have 2 connections. So in our rule generator, I'm hoping that you guys already know what's happening. It's a series of like 0 to 0, 0 to 1, 1 to 0, and so on. So we're pretty much telling like the system, right? We only have 2 connections. So from those 2 connections, right, because you're pretty much matching one number to all of them, you create 4. So for example, what I want to start looking at is what happens again, right, when we start controlling those set of rules. So before I keep going, let's go back to Wasp. Great. So now I want to show you guys a different way to like set up the rules. So in this case, we're going to go to rule from text. So this is a little bit different than the one that we just saw. Where we were specifying exactly what unit we were connecting, and we were specifying to which connection. So in this case, what we are going to do is that rule text allows us to like pretty much type whatever rules we want. So what we're going to do is reference, right, our rule generator output that we can see here in this panel to see what is the syntax, right, that we need to put in here. So as you guys can see, this is not, this is kind of like a square bracket that is giving us the syntax. So we're going to like create our panel. So to do our panel, you guys can do just like the slash and create the panel, or you guys can go to the main params tab, and then you can also kind of like the sticky note, get it. So one of the things that we're going to do here is that we're going to right click it, and then we're going to see a series of options here. So we're going to go to multi-line data. So this is going to change, right, how we see our panel. So what this is allowing us to do is not to create kind of like the one line like we have here, but it's going to be able to help us create a list of rules. So similar to like how you see here, right? There are 4 rules if I start counting 0 as 1. So this is going to allow us to create the same thing. So what I'm going to do here is I'm going to delete the information that there is. I'm going to go capital Y, right? Because that's what my syntax is telling me. And then I'm going to create the upper kind of like line. How do I get the upper line? In my keyboard is above the enter. So in between the backspace and the enter, you can get that symbol there if you press shift and that key. So I hope that everybody's able to get that key. So why kind of like, I don't even know what the name of this key is, but we're just going to call it, I don't know, Mike, do you know the name of this? I don't want to start calling it stick, but you know, it's just, anyways. So we need to,
I actually don't know.
Yeah, like, I don't know what this is the name of this.
I've never even thought about it.
But anyways, this is the symbol that we need because it's part of like the syntax of Wasp to create this rule. So now once I set it, you guys will see that that the text, that the component of the rule text pretty much goes dark gray, which means that it's working. So now if I bring a panel, which you guys don't have to, but I'm just showing you for visualization, you guys can see that now I'm outputting a rule that I just wrote. So that's pretty cool. So now I can set up that rule right there. I can reset it. And then what's happening? So what's happening is that now I'm aggregating only on one direction. And this may seem a little bit meaningless right now, but this is super important because as you guys are starting to like create your own rules, you may want to like go strictly up, strictly down, and you guys will see that depending on like, again, the rules that you're setting, you are starting to like create very specific things. So as you guys can imagine, if I turn this around, it goes the other way. And then another thing to note here, or another thing that I want to make sure that we're noting, is that in the zero connection, what we can see is that the line is going from the middle up. And then in the one connection, the line, the direction, right, is going from the middle down. So what's happening? So if you guys can imagine, and then I'm going to use my annotation setup, is that the other connection, right? This connection here is connecting right above here. So that's why it's making the unit kind of like rotate within itself. So it doesn't matter like how, you know, I go 1, 0, 1 or so on. It's always going to start creating this because one of my directions, right, is going the opposite way as 0. So 0 and 1 right now have very opposite directions, and that's why the geometry, when we see it aggregated, it's rotating, right? It's creating like every other rotation because it can't do anything else. So for example, if I were to bring my geometry back, and then what I'm going to do is go to that direction layer, and then I'm going to create another line that goes up there. And then I'm going to unfreeze my direction, sorry, hide my geometry. I'm going to reconnect my curve. So what I'm going to do is set multiple curves again. So I'm going to go to 0 and then to 1, enter. So now what we're going to see when I preview this is that I get a straight aggregation. Why? Because now I'm not forcing rotation. So this is like super cool too, because that means that you're not just controlling exactly where you're connecting, but you can also start, you know, controlling whether or not you want the geometry like to, you know, force the geometry to rotate, right, within itself to start creating like different aggregations. So you guys, the cool thing about this too is that you guys can like go back and forth. So I can like go back to 0 and 1. This is one of the other reasons why I like to have the pointless. So because it allows you to like, you know, be a little bit more playful. And then you can like go back and start saying, oh, I want to see what happens now when I change the direction to this. So you guys are going to realize that this becomes a lot of like testing back and forth as you go. So don't get frustrated because sometimes it gets a while to like get a good aggregation working for you. But it's definitely, you know, I always like to start with like less connections, less rules, and then once you have like a good control, or you can start predicting the system that you want to do, then it gets start really interesting because then you're able to like really control in which way you want to start outputting these things. So the last thing that I'm going to do here, just so that we can get into the habit of like doing some better previewing, I'm going to do the color swatch. I'm going to change, you guys can like move here and do whatever color you want. And then I preview this, and then that's that. And then we can like maybe bring a few more. So another thing that you guys will realize is that you guys don't need to reset whenever you guys are changing the number of units that you want in the aggregation. Sorry, too much time talking. Give me 1 second. Okay. Sorry, I just drank some water. So when you guys want to keep on adding different elements, you guys don't need to like reset, which is actually pretty cool because as we'll see in a couple of like examples down the road, you can like maybe do some rotations and start changing and getting different aggregations outputs. So the next thing that we're going to do is let's bring a couple more connections before we actually bring the other unit. So what I'm going to do is maybe delete that panel. And then I'm going to copy paste this so that we don't have to redo it. And then rather than previewing, so what I'm going to do is select all this definition. I'm going to go to like the middle of any component, middle mouse click. And then rather than doing disable, what I'm going to do, and preview, is that I'm going to disable, meaning that right now I'm not wasting any computing power on this. This becomes important when you guys have a lot of like kind of like heavier aggregation. So this means that it allows you to open your files a little bit faster, and then it's not computing it at the moment. So what we're going to do is we're going to keep adding a couple of like our additional setups to this. So what we're going to do is let's look at and previewing this guy for a minute. And then what we're going to do is we're going to bring the sides to our setup. So we know that we have 0, 1. So let's bring up a few more. So I'm going to delete the one that I created just so that we can get some rotation in here. And then what I'm going to do is go into my point, right click, set multiple points. So I'm still going to go front, back, and then I'm going to go left, and then I'm going to go right, and then enter. So now what happens, my component goes red because now it has way more points than it does curves. So now we need to update the curves. So set multiple curves. So 0, 1, 2, and 3. So enter. Great. So now we have the system. So let's see, what are we generating with our rule generator? So you guys will see that now with the 4 rules that I have, now I'm generating 16, sorry, with the 4 different connections that I have set up, we are now generating 16 rules. So that's a lot. So now what we're going to do is we're going to use this same text file or like text setup through the rules so that I can start controlling a little bit what I want to get. So just so that you guys can preview this, let's create that. So what's happening here that we can see, maybe 8. Okay. So what's happening here is that, again, I'm connecting absolutely everything, right? So At some points, I can see a lot of like the mismatch, right, from connecting the sides into like the front and the back and so on. So similar to like the other one, what I want to do here is make sure that I'm connecting front to back and then side to side. So let's do that using this new text setup. So what I want to make sure that I do is that I hit enter. So in this enter, now you guys are going to have a new line. So here what we're going to do is we're going to type Y, that symbol that we don't know the name for, and then another Y, and then that symbol, and then 3. So now what I'm going to do is unplug the rule generator. I'm going to preview my preview, hit reset. And now what I can see is that the geometry, right, similar to the other one, is going to start wanting to create this kind of like closed loops. But at the same time, it's also going to start aggregating back and forth, right? So now we can start seeing it a little bit clearer. So it's kind of like creating a cool thing. But one of the things that you guys will notice is that, right, it's going towards one direction. And this is what we have been talking about in terms of how we are actually setting up the different rules. So we can go back in here. Can I preview this? Then I can go back in here and do the other way around. Then I can go the other way around, but then I have to remember to come back and then change the numbers. So I'm pretty much telling it, okay, let's go from 1 to 0, but hey, we can also go from 0 to 1. And then we're doing the same, so from 2 to 3, but also the other way around. So now, if I preview this, right? Rather than going just one direction, now I'm going multiple directions, right? And then I can just start aggregating. Be mindful of your computers or wherever you guys are working with. I know what my computer can take, and hopefully we go through this without me crashing. But again, just make sure that you're always keeping in mind what you guys can do with your computer. Okay, so now this is great. You guys have like a system that is working. You guys could like do the same dispatch here. But now the next thing that I want to do is bring in the other geometry. So let's do that. So what I'm going to do is I'm going to unpreview this guy. And then I'm going to delete this guy because it was just to help me explain you guys what the rule generator was outputting. So what I can do is I can copy paste, bring it down here. And then what I want to do here is, again, disable it. So that means that now we're not, even when things are disabled, it's still being computed. So that's why I normally disable things, so that, again, it's not wasting computing power. Okay, so what I'm going to do here is that I have already set up my one geometry. So what we can do is a couple of things. So this geometry right now has a couple of more connections. So I think that maybe it would be good for us to, let me see. I think that we should let's try to connect this one. So we're going to like repeat the process, but now we're going to have a few more connections, which is okay because we now know how we want to start aggregating this unit. So let's include those 2 points. So because I'm like, even though it's the same geometry, is located somewhere else. So now what I want to do is set one geometry. So So now I know that it's connected. So I'm going to unpreview it for a second. So what we're going to do here is very similar to what we did before. So front, back, side one, side left, then right, then top, and then bottom. Okay. So what we're going to do is set multiple points. So front, back, left side, right side, top, and bottom. So now when I hit enter, I should see my 6 points. And I say 6, you guys would only see up until the number 5. But it's because Grasshopper and most of like programming programs start counting from 0. Okay, so now, as you guys know, we need to like now set our curves, but we have like a nice path set up for us. So front, back, follow the numbers 2, 3, 4, and 5. So enter. Great. So now we have our part Y. So now what I'm going to do is move this a little bit to the side. And then what I'm going to do is I'm going to create the next unit. So our next unit is this kind of like C, we're going to call it C connection. Great. So we need exactly the same setup. So you guys can like copy paste this, or we can start it from scratch. So either way you guys like is fine. So if we guys are starting it from scratch, we need our parts. We need our connection from direction. We need our geometry. We need our point. And we're going to need our curve. And then I'm going to call this Z. So I'm going to do // and then I'm going to type Z, right? So now I'm going to connect this one to here. So that's the name of that one unit. And then what I'm going to do is plug in my geometry. So set one geometry. So now that it's turned green, I can like turn both off. So now they are both referenced. So I know that that's working nicely. So I can start plugging in my geometry to the part. So I'm going to plug it both to the part and then to my connection from direction. So great. The next thing that I'm going to do, set multiple points. So both of the points are at the bottom, only that one is higher than the other. And you guys will also notice that the direction is rotated. So this should give us some interesting outputs. So I always want to make sure that I'm connecting them into the right direction. So my point list, I'm going to make the text a little bit higher or like bigger. Then I can zoom in here. So curve, set multiple curves, 0 and 1, enter. So now I should be good. And then connect both the points and the curves to center and up, and then to the connection. Great. So now what happens? So now what we have is that we have our previous setup for the aggregation that is still valid, but now we have two different units, right? So we have Y and we have C. So what we're going to do here is bring that component that I like. So merge, so it bundles the two different units together. So if I look at the panel so that you guys know what you guys are getting, right? I get a unit, right, that is called Y, and then a unit that is called C. So if I were to just look at one, right, this is C and this is Y. This is so that, again, it's always good to understand what you guys are outputting, because a lot of like Grasshopper is like data management. So this is a good way to like visualize it. So now what we know is that we need to connect these two units into our parts. So you guys will notice here that this is actually flattened. So that means that it's kind of like creating a very simple rule, not rule, sorry, it's creating a very simple list. Because sometimes Grasshopper creates a list of lists. So just be mindful that that's why that is. It's flattening so that it has a very simple list, so that even though you are kind of like merging, let's say, I don't know, like 20 different units, it's okay. So I'm going to preview just the planes. Okay, so now what I'm going to do is use the Wasp rule generator, because I just want to see the chaos that it creates once we plug in everything. So we should see the preview. So now in this case, what's happening is that, be careful, because the rules is just accounting for one of the units. So we need to make sure that it accounts for both, meaning that this C right now has a lot of like connections. So we need to make sure that that's accounted into our aggregation. So now when I say reset, chaos. So what's happening, like what we have been seeing so far, is that everything in all the connections in unit Y, right, are being connected to everything in unit B. So that's what's kind of like stirring up this this aggregation. So what we want to do is, again, start editing what is it that we want to start outputting. So what we're going to do is we are going to come back to our rule text and start writing how is it that we want our different rules to come together. But sorry guys, I'm like thinking that before we do that, let's actually, okay, sorry guys, cool thing that we can do right now. So I'm going to put the rule text on pause just so that we can take a look at a few things that rule generator is doing, or that it can do once it has more than 2 units. So the rule generator has a couple of like different inputs that, as you guys can see, it's called, one of them is called self part. So right now it's connected, it's set up to true as default. So what we're going to do is we're going to create a Boolean toggle. So the Boolean toggle allows me to like toggle a button between true and false. So what I'm going to do is set it to false. Okay. So what you guys are going to see now is that this starts reacting a little bit different. So now what's happening is that if I decrease this to just like fewer, what's happening right now is that it's telling the system, okay, you can like use all the connections in the Y unit and in the C unit and like put them together however you want, but I'm giving you the rule that you can only connect one unit to a different unit. You can never connect a unit to the same unit. So if we like look hard everywhere, you guys are going to see that unit A is always only connected to unit B. And this is going to become a little bit more clear when we are going to filter these 2 units for a second so that we can visualize them a little bit better. So bear with me for 1 second. So what we can do here is that we are going to go to parts, and then we're going to do filter parts by name. So what this is going to allow us to do is to be able to visualize this rule a little bit better because we're going to like custom preview the two different units in different colors. So this was one of like the questions that were asked a little bit earlier on. So this is pretty cool because now what I can do is in the output, I can connect the part, and because this unit has a name, I can connect that name to here. So now what I'm telling it is that this part, this unit, is going to come out through here. So if I move this over here, now I'm only being able to visualize one of the units. And I can see that they don't connect. And they are not connecting because I'm in the Wasp rule generator. There are some other rules that I can play with or that I can work with to like test different like setups. I can like do the self part to false, meaning that the units are not able to connect with one another. Okay, so now I have that. So let's bring the other one. So I can like quickly copy paste that entire thing. And then what I'm going to do here is bring this a little bit lower. And then I'm going to connect this new name over here. So now what do I have? I have one unit, right? The other units, they are both going through my aggregation system, right? Where I have like my rule generator and I'm telling them the only kind of like constraint is that you guys cannot intersect with one another, but then I'm creating different previews for each of the units. But then let's change the color so that we can like see it a little bit better. Great. So now we see how that works. Of course, we may not like this at all, but this is helpful to start understanding what are the different setups that we can start having. So let's quickly look at the other ones, and then we'll move on. So the other one is something that we'll probably not be able to like visualize as much. So in order to visualize it, what I need to do is I'm going to copy my rule generator, my rule generator. But what I'm going to do is that I want to disconnect this toggle. So what I'm going to do is create a little bit of setup. You guys don't have to do the panels. I just want to make sure that I'm showing you exactly what's happening. So in the Wasp rule generators, you guys are creating 64 rules. So 63 plus 0, so that's 64. With only the with an extra rule of not intersecting or not connecting with one another, with themselves. You guys are only creating 23 rules. Okay, so with, let's say, the self connection, right? So this is a little bit different. This means that, for instance, connection 0 from unit Y cannot connect to itself. So what you guys are going to see here, I'm going to disconnect this dude, bring it here, see what is the setup. Default is true, so I want to set it to false. So now you guys are going to see that it's slightly the same as the overall rule generator, but the only difference is that you're getting a few less rules because here we are not allowing the system, we're not allowing, for example, Z to connect with Z0. So Z0 can now no longer connect to Z0 because we're not allowing for the self connections to connect to one another. So I haven't come across an example where I find this, where I need to work with this. I have found examples that, work with this. This is super helpful. I really haven't found anything with this, but it does exist where you want to limit, right, what you're connecting. So here, for instance, you see 54 is 0, 0. Here, there's nowhere we can find that connection, no matter how much you look. And this is why here you can see that you're outputting 64, while in here we're outputting only 51. So it's a good thing to keep in mind. The other quick thing that I want to show you guys is that, again, I can just delete this guy. I'm going to copy paste this. And now I'm going to work with another one that is called type. So for type, it's very helpful to like start understanding what, you know, starts connecting with what. But for this to be able to work, what we need to do is actually give it a type right here. So you guys see that it says T as a list, so it's optional, it's a connection type, and it can only be used with the rule generator component. So this you guys will see what we can connect here. So what I'm going to do is I'm going to go to Y, and then I'm going to say Y dash, underscore connection. And then I'm going to do backslash at the beginning so that it outputs a panel. So I can copy paste this guy, and then I can say C connection, and then I can plug it in here. So now what I'm doing is that I'm giving each of like the connections now have a type. So one type, one type. So what it's now going to do is that it's going to only let the different types connect to one another. So Boolean toggle, and this one works a little bit different. So because the default is set to false, that's how much I remember. So now if we connect it again, we start seeing how now we start creating, right, less rules. So we can like quickly, if you guys want to connect this. So now, right, we're starting to like output something completely different. So in here, what's happening is that Wasp, what it does is that it has a 50% chance whenever it has more than one unit. So in this case, we have 2 units. So we have a 50% chance of like, you know, one starting and then the other one. So it starts, you know, kind of like just similar to self-part, but it only allows to like intersect one another or connect with one another. That makes sense. And because it only it kind of like only allows for the connection of, it only allows for white connection to be connected to white connection, then there's no link between Y and C. So that's why we can see the second unit Z in our aggregation right now, because there's no link between one and the other, because this is telling it, I only want you to connect Y to Y and Z to C. So no matter, so here in the rules, you guys can see we do have like the Y connections, right? But there's no connection between Y and C, no matter how much I look for it. It goes right from Y to Z. So there's a 50-50 chance that I either start, right, with one unit or the other. So no matter what I do, I will always get either one or the other. So again, I haven't found yet the example that could work very nicely with this, but I'm sure eventually, or you guys will find it useful. But I just wanted to make sure that you guys know that there are like different kind of like inputs that you guys can work with within the rule generator that can give you completely different results, but that are a little bit more control than the default one generator. So I'm just going to like plug in that here so that you guys see that. And then what we can do is actually go back into our example so that we can connect both units. So what we're going to do is just going to leave it connected with another one just for fun. And then what I'm going to do is copy paste this, and then I'm going to disable this one. Okay. Then I'm going to come here and I'm going to delete this guys for a sec because I don't need them anymore. It was just to explain you guys how that worked. And then what I'm going to come here to the rule text, and then I'm going to start building from there. So just very quick, that's working, but it's creating chaos, right? So now what I want to go back into the rule text that we already took a look at, that we liked how it started kind of like generating like the aggregations. But now we want to include the second unit. So again, 50% chance that, you know, it chooses one or the other. So whenever it goes orange right now, it's because it wants to start from the second unit, from Z, but we're not giving it any rules, right? Or any indication as to like, okay, this is how you can start with it. So that's why it doesn't know what to do. So if you go to the bubble here, it's going to tell you it cannot place 64 parts. It can only place the very first one where our geometry is set up. So what we can do is not care about this for a second, and then we're going to start building in here. So the cool thing about multi-line is that we can keep on building. Just be mindful though, if you press enter and then you don't write anything, then what happens is that you're creating an empty line. And this is a big no-no because then it's going to say that you're not formatting it correctly. So don't panic. It just means that you need to like not delete the whole thing, just delete that space. So just FYI. So what we're going to do now is let's start adding some of the connections. So what we can do here, now I just did it without noticing. Okay, so what I want to do now here is that I'm going to zoom in so that I can start understanding the connections and then how I want to set them up. So I already know that I want 1 and 0, so 2 and 3, fine. So now maybe I can use, I can start using 4 and 5 to start connecting to C. So what I'm going to do is say, maybe I'm going to copy paste this, but just be careful not to have repeats. So I'm going to say Y5, right? So that, sorry guys, I'm trying to point, but clearly it's not working. So Y5, and I want to connect it to C0, okay? And then I also want to connect Y4. So what I'm going to do is copy paste. I'm going to connect Y4 to C0. So I think that's fine. But then what happens is that in all of our rules right now, we don't have one rule that that starts with C. So I think eventually we're going to get the same issue because we're putting it in the system, but there's no rule that starts with C. So that eventually, right, is going to cause an issue. So the one thing that we can do is now copy paste one of my rules and say, okay, so now let's start with C. And let's say that C0, right, can connect to Y, that symbol 5. So now we should be able to just restart this as many times as we want. And now we're not getting an error because now we have that rule that says, okay, now we can start with unit 2 no matter what. Okay, so let's keep going. So now I'm going to set up with, let's time Y4. So now, yay, everything is working. So now let's connect C1 because right now, as you guys can see, one of the sides of unit 2, right, is free in the open, which is fine if that's, you know, a look that you guys are kind of like aiming for. But the thing now is that we had set up two connection points. So let's try to use them. So now what I can do is, I think I did, yeah. So be careful because you can like hide the numbers. So now let's try C1. And let's see what happens when we connect it to Y4. And then we can do the same thing with Wi-Fi. And then we can start resetting it. Great. So what you guys can see now is that rather than be kind of like aggregated more linearly, now the aggregation is starting, right? To kind of like spread in multiple ways. And this is because unit 2 is starting to like create this opportunity where they can connect at different like kind of like planes, right? We can connect with this plane over here and with this plane over here. So it's allowing us to like offset the other geometry a little bit more. So that's working nicely. Great. So again, you guys can go crazy with this as long, I guess, as your computer allows you to. And then what we can do is also, we can flip it, right? We can do the inverse. So I can say, okay, so let's connect to from Y4 to C1, and then let's do the same. So let's connect to Y5 to C1. Sometimes it's nice for you to like go both ways. Sometimes it isn't, but this is part of it. Like you guys have to like constantly be testing back and forth to see, you know, again, what are the things that you want to, how is the aggregation that you guys want to output. So now we start looking at a little bit more of like that, you know, spread. Why are we seeing a little bit more of that spread? Because now I'm like, you know, putting a few more connections in terms of like how unit Y and unit C are connecting to one another. So again, if I were to like quickly, right, go back, chaos, right, control aggregation. So let me see what other things I want to touch on here. Okay. Okay, guys. So we're going to change a little bit this one so that I can show you guys how to set up the grammar rules, which is actually pretty cool as well. But I want to know if there are any questions or anything before we move on. Is everything good so far?
If you want, I think if you open the Q&A box, you can also see the
question.
Okay. There's 3 now.
Yeah, there's 4.
4, yeah. So one is, what is the Wasp to stochastic aggregation used for?
Okay, so so the stochastic aggregation component is pretty much where all the different units are coming in together, the different rules are coming in together. And what it does is that it creates an aggregation where the only elements that where we're kind of like defining how the different units are going to start coming together as a cluster. So when I say, for example, that that it randomly chooses, or there's a 50% chance, it's because within the stochastic aggregation, there's a little bit of like an initial randomness in terms of like which unit it selects first to start aggregating. So I hope that that answers that question.
I think so.
Okay, so the next one is what is self-C component in input? Okay, so I'm glad that I didn't delete this. So I'm going to go back just to make sure that this is clear. So self-C is what we're looking at. Let me go here 1 second. So each unit, right, we're defining kind of like alone. So this is one unit, and then this is another unit. And then within our first unit, let's say, we have very specific connections. So what, and then unit 2 does exact same thing. So that's why we kind of like have, you know, the connections for our first unit Y, and then our connections for our second unit C. So what self-connection is starting to do is that it allows to connect only, where am I? So it's only allowing for the, where am I here? So it's only allowing for one of the connections from this unit to connect to one of the connections to this unit. So that's what's happening. So it's telling it you cannot connect to your own connection type thing. So that's why we are telling this connection right here, all of these connections are called Y connections, and all of these connections are called C connections. So only Y can connect with C. C cannot connect to C, if that makes sense.
Yeah, I think so.
Okay, so I'll keep going. Can I set a specific dimension of the unit aggregation? When you mean, what do you mean by specific dimension, I guess?
I think they mean like a bounding area. Like, can you say like don't like grow not outside of this area?
Oh, yes, that's what we're going to like look in the, I think it's in tutorial 4, we're going to look at like mesh constraints. So yes, we can like tell it to specifically be inside of a volume or to be repelled by a volume. So we can like, if you want to think about it, create openings within our own aggregations. And then can we do the same with sliders? I guess what was the same with
Yeah, I don't know what that one means.
Yeah.
Maybe they mean rules.
Marco,
But I think I answered this earlier. I just said like you can use any number.
Okay.
Like, you know, that's fine. I think you have one more. Let's just answer this one more and then let you continue.
Comparing to rules hierarchy from example 1, does it make sense to repeat some lines of text in row from text in example 2 to have some rules repeat more often? Yeah, so this is what I was saying. You can choose to repeat some of like the rules back and forth to create like more weight. on those rules so that you get a little bit more of that. So for instance, in the example below, what I was showing you guys was so that we could connect a little bit more elements to unit C so that we could get a little bit more of like a spread out. So definitely.
Cool.
Okay.
So
awesome.
yeah, I'll let you continue.
Okay, awesome. We'll get back to that question. Don't worry. I'm trying to do Q&A a little bit more often so that you guys are not forgetting, or we're in a good place to like keep moving. So let me unpreview this, and then what I want to do is rather than working with the text, I just want to show you guys a different way to set up everything. This is going to take us a little bit more time as the setup, but it gives you a different kind of like flexibility. And then once we're done with this exercise, we pretty much would have seen everything in terms of like rules. And then we're going to move into a few other different setups with like mesh constraints and stuff. So bear with me for a second. So what I think that given the time, let's do this exercise in exercise 3. That's what we're going to do so that we can keep on moving. So I'm going to save this as exercise 2/webinar. And then if everybody can open exercise 3, I'm going to, let's look at the grammar generator there. That's what it will do. Okay, so we are opening exercise 3. So I'm going to stop sharing so that I can open exercise 3 for a sec. No, right. So workshops. Okay, so exercise 3. Okay. Okay, so guys, sorry, since I'm like not sharing right this second, I'm going to go grab more water. So 1 minute. I'll be back in like 1 minute. Okay, Mike, sorry. I just need to grab more water.
It's fine.
Okay, be back. Okay, guys, so I'm back. And let's look at exercise 3. Okay, so for exercise 3, oops, we should see kind of like the same setup. So in this case, we're going to start here with a 2 units, and then we're going to like build them up into our 3 geometries. The way that we're going to do this is a little bit different than before, just because I want to show you like kind of like a different way to like create our own rules. So what I'm going to do is just quickly and preview this so that we know what we're working towards. And then what we are going to do is that I explain you guys all the self parts, self connection, and then the type. But one really cool thing that we can work with is create a grammar, kind of like a grammar rule. So this is now what we're going to like do. So it's very similar to like the way that we were looking at the rule text, but it allows us, I would say sometimes, a little bit more control and to be able to iterate. I find I normally just work with this one because I find that this gives me a lot of like, it's a little bit more tedious at the beginning to like set up. But then once it's set up, you have a lot of like flexibility to like go back and forth and, you know, change a few connections here and there and really start testing the system. So let's start building this from scratch. So I'm going to go to a new document. Again, I suggest you guys do the same. And then what we're going to do is let's start connecting or setting up this geometry. So the one that I'm going to start with is the one that looks like a C. So what I'm going to do is go to Wasp, and then I'm going to bring the things that I need. So from elements, we're getting our connection from direction. We're getting our basic part from parts. And we are going to get our geometry. We are going to get our points. We are going to get our curve. And of course, I want to get my point list just because this helps me so much. And then I'm going to get my slider at 1.5. So I pretty much have like most of my setup except for my name, my unit name. So / C, and then I can just connect it there. Okay, great. So what I'm going to do here is similar to like how we have been working so far. So set one geometry, hit it on the C in Rhino, and then I'm going to unpreview it so that I can look at the different connections. So we have a lot of connections here. So we are not going to get overwhelmed by this, because what we're going to do is that we are going to treat the connections per how do we want them to be connected. So this will make sense in a minute. So what I'm going to do here in points is that rather than selecting all the points, what I'm going to do is just select 2 from
they're asking if you can put on the bifocals.
Oh, sorry guys. Yes, I can. Give me 1 sec. Thank you for the reminder. Great. Okay. So I have set up my geometry. So now what I want to do is I'm going to start isolating all the different connections, kind of like by sectors, or by, let's understand it by like how I would want them to be connected. So for example, I'm going to isolate the connection here so that that can be my front connection. So what I'm going to do is go to my point, and then I'm going to say set multiple points, and then I'm going to select 1 and 2, then hit enter. So now I have 2 points, but you guys see how I haven't selected everything. This this for this part, what I'm going to do is be very selective as to like how is it that I'm choosing my connection. So I'm just going to make sure that I'm like almost, you know, organizing them in different sections. So what I'm going to do here is go to set multiple curves. So I'm going to select 0 and 1. Great. And then I'm going to start plugging in everything. So I'm going to plug my geometry to the part, to the Wasp basic part. And then I'm also going to plug it into my connection from direction. And then I'm going to plug in my center points and then my curve. And then I'm going to plug my connection into the part. Okay. So the next thing that I want to do here is now I want to assign, right, a name to this connection. So how I'm going to do this is that I'm going to call this front. So this is C as in, you know, this unit. You guys don't have to necessarily call it like that. I think that is really useful when you're writing your rules to have it like that, because then you understand where is it coming from, like what unit is it. So I'm going to, oops, so dash dash C, and then I'm going to call this front. And then I'm going to click on panel. So now I have it over here, and then I'm going to connect it there. So that means that this connection right here, right, what it's doing is that it's creating this unit, but only with this connection. So only with 0 and 1. And then I'm calling that C front. So now what I can do is I can copy paste this part, this connection. So I'm going to move this guy a little bit further out, and then I'm going to copy this because it's the same geometry, right? But now what I'm looking at is that I'm looking at a slightly different connection. So in this case, now I don't want to connect the front. What I'm looking to connect is the midpoint. So in the midpoint, what you guys are going to see is that you guys have 2 points, and then you guys have 2 curves. So we are going to be a little bit careful with that one. So maybe first we start with the back. Well, let's just do the mid, but in the mid, let's just try to like select one. So yeah, that's what we'll do. So for the point, let's just set the 1 point for now. And then what we're going to do is select one curve, and we're going to select the curve that is rotated, so that we're going to force some of this geometry to like rotate. So what I'm trying to do, or what I'm trying to like visualize here, is that this connection over here, I want it to like go around here so that then this geometry can somehow rotate inside there. So that's what I'm kind of like aiming for. So let's work with that. So that's why I'm only choosing the 1. So this allows you to like start thinking as to like how is it that you want to start aggregating your different setups. So now we have this mid one. So now what we want to do right here is that I'm going to change the name once that I have input at the point and the curve, and then I'm going to call it mid, as in middle. Okay, so now I have my front connection, I have my middle connection, great. So now what I want to do is set up this back connection. Okay, so let's set that one up. So I can again copy paste, and then what I'm going to do here is I'm going to set 1 point, great, and then I'm going to set just one curve, and then I'm going to set it there, great, and then make sure that you guys are changing the name, and then we're going to call this back. Okay, so now we have 3 connections. We have front, mid, and back. So we are isolating each other one into its own kind of like thing. So the next and last one that we want from here are going to be the top and the bottom. Okay, so copy paste. And then we are going to do top and then bottom. So what I can do here is with the points, I'm going to say set multiple points and then top, bottom, enter, and then the curve. I'll do the same, set multiple curves. So top and then the bottom and then great. So now I should have all of them. I'm going to and preview this. And then here, I can just say top and bottom. But one thing that we need to know is that this may get a little bit tricky, but we're going to leave it like that for right now, and then we'll see a couple of like options as to like how we can like start splitting that one up. So one thing that we can do is I like to keep things as organized as possible. Merge. So what we want to do here is we want to merge all of our different connections, right? That now each of them have its own different kind of like name to it. And then we want to make sure that we're connecting them all here. So similar to like how the aggregation that we were looking at has the flattened setup, this one does too, so that you can like connect multiple connections into it. So it almost like doesn't matter how many you have. And then I always like to delete the one in the bottom, but it's up to you. And then we can replace that one and set that part connection. Great. So now we have our unit 1. So now we need to bring our second unit. So our second unit is a little bit more straightforward. So what I'm going to do with second unit for now is that I'm just going to limit the second unit to the front and the back so that it can just connect to both the front and back of this aggregation. So like I said, I always like to start with like fewer connections, and then you can start building complexity, just so that you're always aware of like what is it that you're trying to output. Sometimes when we start, with way too many things, it's a little bit harder to like fully understand or get an idea of like why things are working the way that they are. So we need to do a very similar setup here. So I'm going to set the geometry. I'm going to put the points. I need my point list, even though it's just 2 points for me. It's always easier because then I can, quickly visualize it and then reference it back if something is not making sense. And just make sure to put the slider so that if you want to visualize it, the text is large enough. And then you can do the curve. Great. Then let's bring Wasp in. Let me move the annotation. And then I need my connection. And I also need my basic part. Okay. So for name // I'm going to call this one I, just because it's just straight. So great. And then I'm going to set up my geometry so I can select it and then say set one geometry. Great. So now I can preview it. So it gives me a little bit more clarity. So now I can say set multiple points. So I'm going to just do front and back, enter. So now I see 0, 1, and then I can do set multiple curves. So 0, 1, and then enter. Great. So now I can just start plugging in information. So the geometry goes both to my Wasp basic part, and it also goes to my connection from direction. So let's get the center points. Let's get the direction. So now I have my connection. Since I'm going to be working with the grammar rules, what I want to make sure is that this one has kind of like name for it. So make sure that you're following the same kind of like format. So if I is with it's capital, make sure that you're also typing it the same way, just for consistency. Front, I'm going to call it front back, just so that I know. And then that's that. Okay. So now let's plug in the connection there. Okay. And then what we're going to do is, let me just move this back here. I like for things to be somewhat aligned so that I know that they now need to be merged so that we can like continue into our aggregation. So what I'm going to do here is double click merge, and then I'm going to connect one part, and then I'm going to connect the other parts. So what I'm trying to do is that now I have all of my connections for unit 1, right? Creating my units, but with names kind of like or types assigned to the specific connections that I'm doing. And then this is pretty much how we have been setting up already our different units. The only difference is that here what I'm doing is indicating how I'm calling that connection. Okay, so I'm just choosing 2 for the time being. Okay, so then it comes into we're going to do our stochastic aggregation, and then we're going to do our rules generator. So this is my both units that I'm going to be connecting to the part over here. You can preview this since we just have 2. And then we have 120. Again, I'm always starting low, so we need to connect our parts into a rule generator so that it knows the different connection, and it has all the information that we already built into our different units. And then we're going to like plug it in. We're going to get our button for reset. And then what we're going to do is, I just want to see what we are outputting before we start changing anything. So get geometry. So I can start seeing an aggregation. Doesn't look too bad. But what I want to quickly do is do the, where am I? The filter by parts so that I can like preview one geometry a little bit different than the other geometry. And this is going to like, I find that this is always like helpful to understand how are the different parts kind of like starting to aggregate. So right now it's giving me the kind of like orange because I need to do the name. One of the reasons why I like to connect it back to this, I know that some people do it a little bit differently. It's because just in case, which you really shouldn't, but in any case that you want to change any of these names, it's just written in one location. So you guys don't have to like track it down in multiple locations, but it's just, you know, if you change it here, then that's it. So I always like to like, you know, kind of like connect it back there. Then you can get your custom preview. And then we can do like a swatch to like visualize it a little bit different. And then I can preview this. Great. And then I can do exactly the same for the other one. So the only thing that I need to do here is just change the name for here. And then make sure that you're changing the color, because if not, it doesn't make sense to do it. Okay, great. So now I'm seeing, right, that's working. That's creating like an aggregation. Great. So now what I want to be able to like use is actually the grammar rules. So I want us to see that right now, the moment, we're generating around 64 rules. So that's a lot. So what I'm going to do is start typing what are the connections that I want to do with one another. But the cool thing right now, or one of the things that I find really helpful is that now, because I have grouped the connections into like different parts, I can kind of like understand what type of connections I want to connect with what. So what I'm going to do is get a panel, make sure that I'm working with multi-line data, and then I'm going to start associating the connections. So for example, let's say that I want to connect my first unit, C front, right? I want to also connect it, right, with that connection. So me saying C front with C front, right now what is doing is that rather than me typing C0 to C0 to then C0, sorry, to 0, 1 to 0 to 1 and then 1 to 0 and then to 1, right? Now I don't need to like write all of this, because now I'm telling it that all the connections, you know, in CFRON need to be connected to all the connections in my unit C as part of like my front connection. So what are my front connections? They are 0 and 1. So by me like writing this rule grammar, what I'm telling the system is, okay, now you are just going to like what am I saying? You're just going to like connect everything to everything within sorry, within this connection. And because we have two, that means that we're generating like 4 different like rule systems. So we can like quickly see what that looks, but I don't think that's going to like really get us right. It gets us to like a few locations, but then we're not going to be able to see that much. There was one that was generating up. Yeah. So we can only get, you know, maybe 2 solutions out of this. So that's why most of them is coming as like orange, because it's telling, you know, we cannot do this many, we cannot create an aggregation with this many units because the rules that you're giving us do not allow for the system to grow. So we need to like keep writing our rules. So the next one that I'm going to do is I'm going to come back to my other unit and I'm going to say, okay, so my other unit also has a front back. So let's see, let's try to like connect that one to this first unit. So I'm going to go to like I front back. It's like the larger than symbol. Connect to C front. Great. So now we have a few more rules and we see how that element now is being incorporated into the equation. So now we see a little bit more of that, but still we're super limited, right, with what we can do in this system. Okay, so let's keep writing more rules. So the other one that I could do is I could do the opposite. So I can say C front, I can connect it to I front back. The other one that I could do too is, let me think. I can do, I can connect the second unit to itself. The third thing that I can do is maybe connect let's go to the C. I'm going to go to the top bottom. I just need to like remember how I wrote it. So top bottom. Let's see what happens when I input that one over here. So C top bottom connected to C top bottom. Okay, so now I'm going to reset this. So now what we are starting to see is that we generate pretty much kind of like a flat plane. And this is happening because we're not connecting anything right now to the sides. So one thing that we could do is use our mid and back and see if that can help us out. So we can connect our mid here with our back. So let's see if that will work. So C mid, let's connect it to our C back. Great. So now what's happening, right, is that we're starting to like get a little bit of like a different connection because now we're getting that this unit, oh, sorry, I scrolling a little bit weird. We're getting like that this back unit, right, is actually rotating. So we don't need to like kind of like put a side connection, because in this case, what we're doing is just by indicating the rotation, right, a different direction that has a rotation set up to it, I can now build not only right in one axis, but now I'm also building in the other axis. So I'm not creating just the plane, but now I'm starting to create more of like a volume. And that was just because what I'm doing is setting like the direction. Remember that we had that direction that was rotated and that I annotated, oh, this is how I envision that unit would rotate. So we are kind of like, you know, predicting a couple of things, a couple of like rules that we think that are going to start helping our system kind of like work. And again, what's happening or the benefit of this right now is that I'm not having to write as many rules. So this is the amount of rules that I would have to write in the text editor that we were doing in exercise 2. But now I'm able to like simplify some of these things a little bit further. So what I want to show you, and then I guess maybe we can do this with the mid-back setup, is that some of the like this connections, if there are 2 or 3, we can actually put them together so that we can like maybe get rid of one of this. So let's try to do that right now, because I think that that would also help you kind of like creating a faster setup. So the way to do that is that I'm going to make sure that that's working nicely. Great. I'm going to copy paste this entire chunk. And the reason why I'm like really copy pasting is so that you guys can like go back and refer to some things if they are interesting to you. Okay, great. So I'm going to disable that because again, we don't want that to be computer in the background if we just unpreview it. So we want to make sure that we're just working with one aggregation system at a time. So what I want to do is, let's say that you guys have, or you guys are working with an aggregation system, or you guys want to work with an aggregation system where you want to use this grammar rules. So the way that we're doing is kind of like setting up our connections through clusters. But there's another way too, where we can actually, for example, set this to as part of like just one connection. So the only reason why I want to go through this is because that this can like help you, for example, simplify this. So rather than having 4 right now, maybe we could have 3. We could even have a little bit less, but I don't want to complicate it so much. I just want to make sure that you guys know the basics as to like how we could start maybe combining some of this too, so that it simplifies a little bit our system. So what I'm going to do is I'm just going to zoom in here, and then I'm going to delete this guy that is at the back. So I'm just going to delete it. So it's deleting in Rhino. So sorry, I'm going to delete it in Grasshopper. Great. So now what I want to do is that I'm going to have to like set up the mid again. So set multiple points. So again, I'm going to just set 1 point here, and then I'm going to set the point at the back. So enter. So now I should have 0 and 1. And now I'm going to set up multiple curves. So I'm going to set up the one to the side, the one in the middle, and then the one at the back. So hit enter. So now I have both. But I want to call them something different. So what I can do is go to multi-line data. So you can like right click on any panel and say multi-line data. So that's what is going to like allow you to kind of like create a list. So if I now double click on it, I can like hit enter, and then I can say C, and then I can say back. So the cool thing about this is that then you can start storing, right, different connections with different names. You just need to be very mindful of the order. And again, this is why I like to have the point list, because then you can say, okay, so 0 becomes my middle connection in the C unit. And then my 1, right, becomes my back connection in the C unit. Of course, sometimes you have to highlight it because we have other ones, but this is, I find, a pretty cool system. So now what happens is that I can tidy up this a little bit more. I can get rid of this connection by just zooming in. You guys will see the plus and the minus, so you can get rid of that. And then you guys will notice that there's maybe not that much difference in our aggregation, but now we have kind of like cleaned up our definition to make it more efficient. So I don't even have to change that because it's going to work exactly the same way. It's just a matter of like, you know, being able to kind of like put a little bit more of control within your connection. So I hope that that makes sense. So now we can even bring this, you know, a little bit lower. So just, I just think that sometimes it's easier when there are less things than more things. But, okay. So that's that. So now what I want to do is, let's bring the other geometry to the system. So that's what we'll do now. So let's go back and let's copy paste this. Let's disable this one. And then what we're going to do is we're going to create another unit. Okay, so to create the other unit, what you guys can do is that I'm going to disable this for a second so that I can build my other unit. So I'm going to go into geometry right here. And then I'm going to set this one up for the sake of time. Let's not reference everything again. Let's just work from this so that, because we are at 12 right now. So I want to make sure that we go through the other exercises. Okay, so let's set up this geometry right here. So what we're going to do is that we need our same components. So I need my connection from direction. I need my the basic part. Great. And then I need my geometry. I need my point. And I need my curve. Great. And then I need my point list. And then I'm going to bring a slider in here. Great, so now I have all the information that I need. So I'm going to right click. I'm going to zoom in so that you guys can see a little bit better. I'm going to right click, not zoom in, but right click on set geometry. And then I'm going to click that larger unit. And I'm going to call that unit //O. Just because it's the closest to any letter. Okay, so that's O. If you're using 0, just make sure that you don't get confused, but I normally like to use letters. Okay, so let's start plugging in things. So I'm going to connect my geometry, great, and then I'm going to connect my geometry right here as well. I'm going to connect the points to my point list, and then my slider to make the text a little bit larger. And then I think that what I'm going to do is I'm going to start simple with this. So let's just connect the top, the front and the back. So I'm going to select those two and then go to set multiple points. Sorry. And then I should have them. So 0 and 1, there you go. So you can make it with the slider a little bit larger so that you can read it. So for the curve, right click, set multiple curves, and then 0 and 1, and then enter. So now I should have my curves, my points. So I'm going to plug them in to my connection from direction. So center, and then the direction. Great, and then the connection back here. So now we have this unit. Because we're dealing with grammars, that means that we also need to bring a panel. So I can just copy paste the panel from my previous unit I, and then I can double click it here, and then I can make sure that this is O. So great. Now I can plug it in here. So now I have this geometry all set up. I know that the connections are working because we can see the planes that are being displayed at the location position. So now I'm going to preview everything. Not everything, but just this connection direction, just because I find it a little bit distracting, but it's up to you guys. So now the next thing is that I have my parts here. So as we said before, the cool thing about here is that I can pretty much add as many units as I want. So I have already my system in place. So what I'm going to do is I'm going to grab this part over here, and then I'm going to plug it to 3. And then it's going to say D4. You guys don't have to. I just like to keep it a little bit cleaner. So I normally go in, zoom in, and just delete the other one. Like I said, it's just more me trying to keep the definition clean. So if I now enable back my stochastic aggregation, and then I reset, you see that no matter how many times I reset, my O unit is never there. And it's because we need to set up the rules for it. And then you guys will also see that at some points, right, it's giving you orange, and it's because it couldn't place any parts, because again, with the stochastic aggregation, it picks randomly either this one or this one or this one to start. So there's 33.333 chance that it's going to choose this one. And if there are no rules for this, then this whole system doesn't work. I love annotating, guys, so sorry. So what we're going to do is we're going to come to our rule generator and to like our grammar, and then we're going to like bring in our rule for our O. So we're going to say that we can connect our C front. So I'm going to copy paste this. So we're going to say that we can connect our C front to our O front back. I believe that's how I called it. Let me check. O front back. Yeah, it's very important that you guys, if you guys are getting an error, it's probably maybe because you guys have a typo. That's why sometimes I always try to like copy paste from here. But again, it's up to you. So now we're telling the rules. Yes, we're including the third unit, the O unit. But the problem is that we're not starting from that O unit. We're always starting from like this C or I unit. So that means that I eventually need to say, okay, O, right? Okay, let's say that it can connect to this C front too. Okay, great. So now if I reset the system, right, what's happening? It's actually there, but I can't see it. Why? Because we haven't set a preview for it. So to be able to like display, we need to make sure that we are creating like a preview for it. So right now we have a preview for both of our units. So for both our C unit and our I unit. So now we need to like copy paste this guy so that we can like preview our O unit. So I'm just going to like drag the name, try to like keep it tidy. Great. So now we can see our O units. So great, there it is. And then we can choose to, have it as a different color. And then we can also start aggregating it a little bit more. So now, one of the things that you guys will realize is that there's significantly more of other units rather than the O unit. And it's because, again, we don't have that many rules that include our O unit. So another rule that we could have is, we can say, okay, whenever there's a I unit, maybe we bring in another O unit. And again, this is a good system because then rather than me typing, I'm just curious to know what point are we at. Like we're at 32 and I'm just like, keeping track and keeping the logic of like 8 of them. So it's a pretty cool, system, I would say. And then I can just like restart it, right? And then I can start seeing a little bit more. In this case, I want to see, so I sometimes do this and I shouldn't, is that you guys shouldn't really create another slider that says 5,000 and then plug it in because it will definitely slow down your computer. One of the things that I found that works a little bit better is that if you guys right click on the slider and then just change the maximum to, let's say, 3,000, click on the check one and say okay. What it does is that the system still has 1,000. You guys have increased the slider, but you're not drastically changing it from 1,000 to 3,000. So here, I can slowly start increasing the numbers. Cool. Okay, great. So what we're doing right now is we have, I'm just going to do a super quick recap. So we have our 3 units right now. And what we have done is that for our first unit, we have kind of like create different groups of connections so that we can like control a little bit better how is it that we're generating our rules. So rather than typing absolutely all the connections and keeping track of like the different connections that we have on hand, what now we're trying to say is, no, this is the way that I'm controlling the connections, and let the rule generator actually create all the different connections, but in accordance, right, to how I am setting them up. So that's that. Then the other thing that we are doing that is working out nicely is that because each of our parts have a name, what we're doing is that we're using the filter parts to like start isolating all the parts separately. So one of the advantages here is that, you know, you guys could start baking some of these geometries also separately, so that you can like store them in different layers so that when rendering comes it's a little bit easier. And then of course here, you know, you guys can also use some other like Grasshopper components like the one that we were using in exercise 1, like this patch, to like really start even if you guys want segregating a little bit more of that unit. And then just make sure that you guys are always connecting like the right name. So remember when we didn't have this one, we were not able to like preview one of the components. Just make sure, because sometimes it's not because there's something wrong with a rule, but it's because you're not outputting it. So when the component by itself is this darker gray, means that there's no preview. So it doesn't mean that it's not outputting any data, but it means that it's not generating any geometry for you to display. So that's why we need our get part geometry from Wasp. But this is like connected into like our filter parts, so that we can really start getting, you know, our first unit, our second unit, and then our third unit. So I hope that this makes sense. So I'm going to quickly check if you guys have any questions, because the next one we are going to take a look at a couple other things. So we're going to look at, again, multiple geometries, multiple connections, but we're also going to start looking at mesh constraints and also assigning attributes. So assigning a more detailed geometry than so that you guys can like get more detail. Okay, so Q&A. So what is the Wasp geometry panel used for? So where is that Wasp geometry panel? I don't know which one you're referring to, so.
I wasn't sure either. Exactly.
Okay, so Constantina, I don't know if you want to elaborate a little bit on your questions so that we can make sure that we're giving you the right answer. So the first greater than signs is for grammar rules only. Yes. So I don't know why, but I think that when you're connecting, you're writing rules that are with connection that are actually the connection, sorry, and not the very specific. So this connection is actually a group, right, of 2 points. So it's not really the one single connection. So that's why the rules are slightly different, because here what I'm storing is actually 2 connections. So this becomes, right, a group of 2 connections. So that's why this syntax is just slightly different than the other one, because in here, what we're actually seeing is the zeros and ones that we're outputting in the other ones, or that we were writing for the Wasp text rule component. So I hope that that makes sense. So you just need to be careful that when you're doing grammar rules into the rule generator, it's just a little bit of like a different syntax than the other one. That's all. It's just a little bit of like, not a coincidence, but the way that I do it, that I'm always trying to like type the actual unit before the name of like the group of connections, just because it makes it easier for me to like understand to understand what is it that I'm connecting. And then there's another question: does Wasp code has a relation to the logic, or is based on the wave function collapse algorithm? So I'm not 100% sure about this question. Wasp has a collapse algorithm embedded into it. So as you guys can see from like the different aggregations that we're creating, right, the geometries are not colliding with one another. I don't know exactly what's the wave function. Mike, I don't know if you know that.
Yeah, I'm not too familiar with like the specifics of the function. It might be written on the GitHub.
Yeah, I'm not 100% sure. I just know that yes, it does have like a collider algorithm embedded into it. So that's definitely that. So then the other question, is there time you can go over how the geometry for the poster was generated? Yeah, we'll go through that one. Maybe not like we'll go that one for how like we generated the end mesh. So I hope that that's helpful, but we'll definitely see it. So Constantine is saying, if you wouldn't use a geometry panel, would I have a problem with my unit connections? You mean like this geometry component? I still don't fully get it.
I guess let's just assume it's that.
Yeah.
I guess.
Okay. You definitely need this, because unless you're creating like your geometry directly from Grasshopper, then yeah, you need to like somehow reference your geometry. It doesn't have to be necessarily the geometry component, you know, but you definitely need to reference something as the unit, because if not, it doesn't have pretty much any like information that it can like aggregate. Then there's another question: can we simplify it using bounding box, as it has 4 faces? And lastly, so yeah, you can like simplify different geometries and use the 4 faces. In this case, what you guys can see is that if I were to simplify it with a box, let's say, right, I wouldn't be able to connect, let's say, this side to that side. And more so within a box, you guys would just need to like make sure it's just a little bit, I think, more complicated than it needs to be. With a box, then you need to make sure that you're defining some of like the centers, but then this becomes a problem, because then in your box kind of like collider, you're creating an issue, because now that point in the middle is not outside of like your box boundary. So it wouldn't take this connection. It would give you an error for that one. So that's one. So for this one, for this tiny one, yeah, you could. So, and lastly, say our model geometry is organic in form, flowy, not straight faces. How can we place the curve onto the surface? I'm assuming using project curves onto the surface component. Yes. So I think that you're asking two different questions here. So in the next exercise, what we're going to do is actually use a box as a simplification of like the geometry that we actually want to aggregate, so that the aggregation moves or computes everything just a little bit faster. And then we're going to display the attribute that becomes a detailed geometry. And that has, you know, like a more organic shape. And then you can use either mesh constraints or fields. That's something that we're going to do in the next exercise. Mesh constraints, so that you can like start placing your geometry on like a more organic output if you want to. Then the other question is, can we use Wasps to create a logic pattern that makes the geometry to diminish depending upon the distance from the original geometry? Like, can we make the geometry to adapt to the adjacents? Yes, that's something that you can do. You can, like, for example, this is why the safe load here. So for example, you could like save one of your aggregations and then load it into a different file, and then you can start working from that. So that's something that you can do. And then can we input polyhedrons that reduces number of sides and their connections depending upon the produced geometries? I'm not sure I'm understanding that question. That reduces the number of sides and their connections depending upon. So if I'm understanding the question correctly, one of the things that you could do, for example, is with mesh constraint, you could repel the geometry from heading into like a certain direction, for example. Or you can like constrain the geometry to stay within a certain parameter. So I think that I already answered. Can we simplify the module with complex shapes using bounding box? Yeah, the thing with these geometries that we're showing you guys is that they are not super detailed or have a lot of they are still simple enough for like the aggregation to kind of like compute it without having it to simplify as a box. So for example, if you guys wanted to like keep working with this geometry and use those ones as side connections, if you were working with a box, you wouldn't be able to. So that's one of the things that just keep in mind, I guess. And then any advice for working with curved faces or double curved surfaces? Does it work similar in terms of like getting the connections as long as we use a point and a curve? Yeah, so what you can do is that, like I said, if you have, let's say you have a box, right? And then you want to have like a super curved geometry inside it, that's completely fine. You just need to make sure that kind of like the boundaries of the surface that you want fit well within the box, because then the box is going to have the connections, right? So if there's nothing here, you just need to make sure that you're putting like your points and your directions so that the geometry inside that box can easily connect. So I think that's all. Are we going to review creating the original geometry with the curves? You mean this geometries? This geometries, the way that you guys can create it is, you know, with a series of like polylines and then extrusions. But I can elaborate on those ones. But yeah, I think that's it for now. So I'll keep going. Okay. So if you guys want, we can do one thing very quickly, and this is part of why I think that this system is great. So what we can do is let's copy paste this to the bottom quickly. Oh, sorry. And then we can input a couple of more connections so that you can see the advantage of, in this case, not using a bounding box. So for instance, what I can do is go to that second unit that I have right there. And that what I can do is I'm going to give myself a little bit more space. And then I'm going to copy paste this one. And then what I can do, for example, here is that I'm going to connect the sides too. So what I'm going to do is say set multiple points, and then I'm going to do 1 and 2. So one of them is actually a little bit offset. So that's good so that it doesn't fully stack. So I'm just going to use those two. And then I'm going to say set multiple curves. So I'm going to go to 0 and then to 1, hit enter. And then what I'm going to call this, I'm going to say I sides. So now I'm going to create a merge component here so that I can combine both of those setups for those connections, and then put it here. And then of course it's not going to appear until I get it here. So I'm actually going to copy it from here. So I'm going to come here, Control C, and then I can come back here and then say I sides, connect to I sides. And then what I can do is preview all those 3, and then I'm going to hit reset. And I just realized that this is a super high number, so it may take a while. So now we can start seeing a little bit of like that aggregation as well. So again, depending on the units that you guys have and how complex the geometry is, you may or may not want to like generate a bounding box. So this is the example that we're going to see in the next exercise as to like how we're holding information or like detailed geometry inside a bounding box. Okay, so I'm going to leave this as this right now. And then make sure that if you have a high number, maybe disable this so that next time that you're opening this file, it doesn't crash or anything. Okay, so I'm going to stop sharing, and then if everybody can go to exercise 4, that would be great. So safe. Sorry, I'm closing the file as well so that it runs a little bit faster on the other one. Okay, so I'm opening exercise 4 now. Okay, and it's 12:30. Mike, quick question.
Yes.
Can we take a like 2 or 5 minute break, and then
Sure.
we can just like then plug through or go through the final two exercises. I think we're
Yeah,
good. Okay.
that's work.
Okay, great guys. So let's take a like 5 minute break. So we'll be back at 12:35. Okay. Okay, guys, so I hope everybody's back. So now what we're going to do is again work with a very similar setup, but now in this case, as you guys can see the layers in Rhino, there are a few more things to go over. So we have two different units. So we have one that is called unit bridge, which is going to be this one, and then another one that is called unit pod. So what we're going to do with unit pod is that you guys are going to see one that says box. You guys don't have to unpreview it. I'm just going to do it so that you guys can see what's in there. But what that has is that is going to act as our collider box so that it can like aggregate, let's say, taking into account that simple kind of like box geometry. And then it's going to carry this detailed geometry as kind of like a value that then we're going to be able to like preview. And if I'm not mistaken, what I did here to like help us a little bit in the setup is that I put actually one a slightly different detailed geometry that is very similar to like the other one, but just so that we can actually generate 3 different units rather than 2. So we're going to do exactly the same, but just keep in mind that now we're dealing with like 3 units. 2 of them are pretty much are very similar to one another, except for one thing that we'll look in a minute, and they are both kind of like embedded within this box constraint. And then what we have is this bridge connection. And then for this one, what we are doing is that the geometry is actually extending beyond the box, because then what we're going to do is we are accounting for, in this case, the additional space between the connection of this bridge and this kind of like box collider. And to actually, for the bridge to reach the geometry, it needs to be a little bit longer. So here is where we're kind of like tricking the system, because we know that our bridge is going to get connected with the sides. So we know that they are not going to be colliding within themselves, but we do want the bridge to like reach the detailed geometry, and that's why it's kind of like extended beyond the box. We do want to work with the boxes though, because the geometries, especially the one in the pot, is a mesh that has has certain level of smoothness, so it has, you know, it's a heavier geometry. Okay, so we're going to start this guy from scratch, and then let's set this thing up. So we are going to go to Wasp. And then we know already how to start our setup. So this time what I'm going to do too is that now that we know how to like do our grammar rules, we're also going to take those into account. So what we're going to do is like set up the upside and like the up and the downside. We're going to like put it into a group, a different connection group than all the sides. And then we may avoid some of like the connection for one of like the pots. So that's what we'll do. So let's start by bringing our geometry. So this is going to be our box. So what I'm going to do is set the one geometry. Great, so now I have like my box input. So now what I can do is, I'm wondering if it's easier or more difficult to visualize. I think that we should keep the box on for right this second, just because if not, it may be a little bit confusing with the detailed geometry. Okay, so the next thing that I need is my connection from direction. Then my next thing that I need is my basic part. So what I'm going to do here is I'm going to call this pod A. So it doesn't matter how you guys write it as long as you guys are consistent all throughout. So I'm going to connect my geometry here, there, great. And then what I'm going to do is I'm going to connect first all the sides. So I'm going to get my point. I'm going to get my point list. Then I'm going to go to 1.5 so that I can like visualize it a little bit larger. In this case, I think it's being now obscured by the geometry. No, it's because I haven't input it yet. So sorry about that. So now what I'm going to do, set multiple points. So now I'm going to go through all the sides. So I should have in total 4 points. So I'm going to start 1, 2, 3, and 4, and then hit enter. So now the numbers are huge. Great. So now I think I'm going to unpreview so that I can like see it a little bit better. Great. So now I have my points. Now I want my curves. And now I'm going to say set multiple curves, 0, 1, 2, 3, enter. And now I'm going to connect them to my direction. Great. And then I'm going to call this.
Hey, Alejandra, can you put the bifocal?
Oh, yes, sorry. There you go. Okay. And then the next thing that I'm going to do is double click on the canvas / so that I can like get the panel. And then I'm going to say pod A, and then I'm going to say side. So now I know that all of these connections are the ones from the sides. And then once I select the connection from direction, what I can see is how it's mapping all the planes. So now what I can do is plug it into connection over there. So now I have it. The next thing that I'm going to do is I'm going to copy paste this. And then this time what I'm going to get is just the up and then the down connection. So what I'm going to do is right click on my points, say set multiple points. So I'm going to go up and then down and then press enter. So now I should have the 0, the 1. And now I'm going to go to curve, right click, set multiple curves. And then I'm going to select the 0, the 1, hit enter. Now I should have it. So the next thing that I'm going to do is merge these two connections. I'm going to move this a little bit further so that it's a little bit cleaner. So what I'm doing is I'm combining my two groups of connections into the merge component so that then I can like pass it through my connection for this unit. So that means that pod A now has 2 different connection groups, pod A side that has 4, and then pod A, this is why I like to go over things, up, down. So make sure that all of your group connections are different, because if not, then you're kind of like creating a little bit of like chaos between your system. So now the thing that we need to do a little bit different is that now we need to like tell this part that our unit is actually not the box, but our unit is a little bit of like a detailed geometry. So what I'm going to do is preview that guy. And what we want to do is go back to Wasp, and then we are going to get an attribute. So I want to go to Wasp and elements and then get the attributes. So what this is going to do is that we're going to connect this attribute to our part right here, so that when we're creating the aggregation, Wasp is using right the box to check that the geometries are not colliding with one another. But when we want to, like, at the end visualize the geometry, I want to make sure that I'm actually visualizing the detailed geometry and not the box. So in order to do that, what I'm going to do here is I'm going to go to my Wasp attribute, and then I'm going to do // and then I'm going to do pod A, and then underscore detail. So this is the way that I'm going to, like, name this ID, so that then when I'm doing my filter, right, when I'm like doing my display, I know exactly what I'm looking for. Okay, so, and then this one, we're going to connect it all the way to our part right there. So now our part has the collider geometry, it has the connection, and it also has the attribute. But we haven't really put anything as the attribute. So you will see that there's no input here that says geometry, and it's because we have a value list. So a value list is, it can be any data. So it doesn't have to be necessarily like a geometry. I haven't found the opportunity where I'm like not displaying something other than geometry, but I think it's good for you guys to like know that you guys can output something else. And then it's asking if it's transformable. So we need to make sure that we create a Boolean toggle here that says true, because we want to make sure that we are pretty much passing this information that we can transform that box that we're using as a collider kind of like test or check as part of the algorithm. We want to make sure that yes, we can transform it to, like, you know, whatever we're inputting here as a value. Okay, great. So now we have that. So what I'm going to do is preview this box geometry, and then what I want you guys to do is I want you guys to hide the orange pod attribute. So I want you guys to only see the blue one. Okay. And the reason for this, I'll explain this in a minute, but I pretty much put two together so that we can go through this part a little bit faster. And that's the really only reason. You could have it separate, but I just wanted to spare us a few minutes like setting this up, since pretty much both can be set up the same way. But just please make sure that the orange one, that is attribute one, we're like taking, and previewing for this part. The second thing that I want you guys to take into account is that as part of like your geometry, you may want to have different materials. So meaning that maybe I want this frame to be, you know, metal. Maybe I want this to be like a lighter metal, and then maybe I want those openings to be glass. So there's a way for us to like be able to actually pass that as a value, and then, you know, filter it out so that we can even bake it separately, which I think could be, you know, gives you a lot of like advantage in terms of like, you know, how many things you want to how many things you are working with as part of like your unit glazing structure, whatever you guys want. So what I'm going to do is set up 3 different geometries. So I'm going to like copy paste 3 different geometries. And the reason for those 3 is because I want the frame separately. So the frame, I'm going to set it up as one geometry. And then what I'm going to do is I'm going to hide it. Then the body of the pod, I want to set it up as a different geometry. So I'm going to, again, set up another geometry. And then in Rhino, I'm going to hide it. So this way I can like kind of like keep track of what I'm doing. The next thing that I'm going to do, and that you guys can do too, is you can preview your lines so that you can like quickly select your window. That way you're not selecting lines by mistake. Otherwise, you can just like go select one, and with shift, you can select the other ones. So all of like the glazing, I wanted to go into like another one. So I'm going to say set multiple geometries. So great. Now, if I were to hide that, now I have my entire system here. And then I can just like check it by clicking, because then it's going to highlight in green or as green the geometry. So now I see that that's good. I have all the windows. Great. So now what I need to do is merge this geometry. So I want to make sure that I put it in order, because this is going to help me when I'm actually like selecting some of like the items. So we want to make sure that the frame goes first, the body goes second, and then the glazing goes third. So that's what I'm going to do there. And then I'm going to pass the value. And then what do we have? And then I can, you guys can just do and preview this if you guys want. At least preview one set of them. Okay. So now that's great. I have like my first pod, so that's working. So I have my collider box that I had on preview. So that's the one that is going to like get aggregated. Then I have my connections. So the sides, right, are different than the up and down, which is great. And then I have like my attribute geometry that I'm passing as my pod A detail. Okay, so now what we're going to do is let's create pod B. Okay, so how do I create pod B? So I'm going to create pod B from pod A. So I'm just going to copy paste this. Okay, what you guys can do here, I think that you guys should unpreview this so that it's easy to see. You're still seeing it because we just copied pod A, but now we want to use a different reference. So the one thing that we're going to do first of all is change the geometry. So the geometry is the same in terms of like the frame, so we don't have to worry about that. What we need to do is we have the frame. We need to change both the body and the windows. So the body is slightly different. It just doesn't have what we're going to do as a bridge connection on some of the sides. So what we're going to do is just select the body, and then we're going to go to that geometry and then set one geometry. So by doing that, what it's doing is that it's basically replacing the previous geometry with this one. So what I'm going to do is similar, high, and then I can see all what I want to be as glazing. So now I'm going to select everything. And then I'm going to say at the last one, set multiple geometries. And then I'm going to hide this guy as well. So now I'm going to unpreview that one because I want to unpreview the merge. Great. So now I have my pod B. But with my pod B, the only difference is that I don't want anything to be connected along the 1 and the 3 connections. So I just want the 0 and the 2. So what I'm going to do is I'm going to bring back my lines that also has my points. So what I'm going to do is go back to points in the connection that is pod 8 side that we're going to change in a minute to B. And then we're going to do set multiple points. So we're going to do 0 and 2. hit enter. So now that becomes 0 and 1. And then the curve, what we're going to do is say set multiple curves. So we're going to do 0 and 1, hit enter. And now our pod B just has this very slightly different geometry and connection. So the next thing that we're going to do is go through all of our text and make sure that we're using pod B and not pod A. So pod A side needs to be now pod B side. Same with here. And then same with here. Okay, so now we have one. That one is also working. Okay, great. And now we're going to bring the bridge, which is a little bit simpler. So for the bridge, what we're going to need is, again, the same. So we're going to go connection from direction. We're going to set up our geometry. We're going to set up our points, our point list. We're going to make it a little bit larger. Then we're going to do our curve. And then we're going to get our basic part. Great. So the geometry, right, that we're going to set is the box. Okay. We have now the box. So one of the things that you guys can do is and preview or hide the one that says bridge geometry so that we can see the lines and the points. So you guys can also preview or hide bridge box. So now I should just have like my box right there. So I'm going to connect this to my part geometry. I'm going to call this my / bridge. Great. Oops. So that to name. Okay, so now I'm starting to like get my bridge part. So now what I'm going to do is set up my points. So I'm going to do point, right click, set multiple points. 1, 2, enter. And then I'm going to do set multiple curves. So 0, 1, enter, great. And then I'm going to connect this to my center and to my up direction. And here what we're missing is our geometry. So now we know that it's working because now we see our planes that I'm going to unpreview, and that gets connected to our connection in the part. So what is the next thing? We also need an attribute. So I'm going to go to Wasp attribute, and I'm going to connect it to the attribute right here. So now in this case, what I want is the bridge geometry. And in this one, I want to call this bridge detail. Great. So now I have like the ID for that. And then I'm going to make sure that I'm bringing my Boolean toggle. Set it to true so that that is transformable. And then for the geometry, I just have like the one geometry. So I'm going to select and then say set one geometry. And then you guys can preview it again. So now we're good. So now we have our 3 units that each of them have their own attributes. So for like the pots, what we're doing is that we're actually isolating or like inputting like the different parts separately with the aim, sorry, with the aim that that then we can bake them in separate layers or use different materials for the different geometries. Okay, so now what you guys can do is kind of like set all these parts kind of like parallel or like in the same line so that it's just easier to understand that they are all doing the same. So what I'm going to do now is merge. So I'm going to get pod A, I'm going to get pod B, and then I'm going to get my bridge. And just very quickly, make sure that pod B has everything saying pod B, okay? And then what's next? I'm going to delete that input. And now that I have all my parts, what I need to do is create my aggregation. So again, I'm going to do my stochastic aggregation. I'm going to connect my parts. I'm going to start with 120. I'm going to get my rules from rule generator. I'm going to connect the parts, set this to rules. I'm going to get my button so that I can reset my geometries. And then to visualize this, I'm going to get my part geometry, just so that we can quickly see what's happening. So when we see this, no matter what I do, right now, the only thing that I start to see are not only boxes, but also that my bridges that are supposed to just be horizontal are now also vertical. So one of the things that I quickly need to do is to start using my connection groups so that I can start indicating what is it that I want to connect with what. So let's write those next. So I'm going to get my panel. I'm going to make sure that I'm doing multi-line data. And then what I'm going to do is start writing some of my rules, but you guys can actually, what I like doing is kind of like copy pasting this guy. Okay. So I'm going to say that pod A side can connect to pod A side. Very straightforward. So then what I'm going to do is copy paste and say that now pod A can connect to pod B. And what else do we want to do? So we also want pod A side to be able to connect to, so what I'm going to do here so that it makes a little bit more sense. We want to make sure that the sides for both pod A and pod B are able to connect to the bridge sides. So what I'm going to do here is bring the, not the bridge detail, but the bridge side that I actually didn't set up. So this is why sometimes it's good to go back. So here, what I want to make sure that I'm doing is typing bridge side. So this is something that I missed as part of like the initial steps. So I need to make sure that I have my connection type here so that then I can indicate that I want to connect this bridge side. So I'm going to copy paste to my pod B side and my pod A side. So I'm typing my rules right here. So bridge side, right now I wanted to connect to both pod A and pod B. So pod A. And then I can copy paste this so it can be pod B. Okay, so now what I can do is I could set it up the other way as well. So I could say I want to make sure that pod A can connect to bridge side. And then I can do the same thing for here. So I'm starting to like write my rules. Then the other thing that I want is that we can like quickly check this, but we haven't connected up and down. So it may be just, we need to make sure, yeah. So right now what's happening is that we get kind of like a flat aggregation at the moment. So we want to make sure that we're connecting our up and down connection so that we can start stacking and building up with this system. So the next thing that I'm going to do is say, is actually copy this so that I just don't get any typos. So, and then I can just change this to A, and then I can copy paste so that I can go the other way as well. So I can do A and B. Okay, so what am I connecting? I'm connecting pod A side to pod B side, and then I'm also connecting A with A. I'm also connecting the bridge side to pod A side. I'm also connecting the pod B side, so with the bridge side. And then I'm also connecting up and down A and B together. So that's going to like generate for me all the different rules that luckily I don't have to like write those 55 rules. And now what I'm going to do is reset. So now I can start seeing like that aggregation, right? So now as I grow, it starts growing. But I want to actually also see my my detailed geometry, and I want to be able to like assign different kind of like materials or like previews to each of the geometry. So what I'm going to do is I'm going to use the same or a similar system that we have been using so far, that is going to the parts and then doing the filter. So in this case, what we're going to do is 3 of these ones. We're going to need 3 different ones. So I'm going to do one, and then we're going to use that as a base to like copy and paste that. So I'm going to get the part, right? And then what I'm going to do is bring it up here so that I can connect the name to here. I like doing that. You guys can just copy it again. It doesn't matter as long as you're consistent with the names. I just like to do it this way. So in this sense, what we're going to do is that we have a couple of ways of like setting this up. So what we're going to do is we still need here the part geometry. So I'm going to preview this guy. We still need here the part geometry. And then what we're going to do is also get the attribute by name. So in this case, we're going to connect that part, but then we need that ID number or that ID name. That is actually the pod A detail. So I'm going to bring it over here. So now it's telling me an error because I accidentally connected the mask rather than the part out. So I'm going to connect the part, then I have the ID. Great. So now you guys can see that I'm seeing both. I'm seeing the part geometry, and I'm also seeing the attribute geometry. So I can see like my pot right there. So one of the things that you guys can do is that you can do stream filter. So this would allow you guys to like with a value list that we're going to set up, it's going to like allow us to pretty much select by using this value list whether you want to preview this one or that one. So what we can do is connect our initial geometry to 0 and then our attributes to 1. And then what we can do is double click on this. value list, and what it's going to give you is a panel. So you guys, for example, we can write here basic, and then at 2 we can write detailed geometry or detailed geom. And then what I'm going to do is delete the other ones because I don't need them. So when I do basic, right now is giving me 1. So sorry, here we need to put 0 and here we need to put 1. So that the basic geometry, that is this part geometry, actually tells this filter, I want to display what we have in our 0 input. But then when we change that to detailed geometry, then it's going to tell it, now I want to be able to display my attribute. So right now we have that basic geometry, and now we have like our detailed geometry. So that's one thing that we can do. And then we can here get to our custom preview. And select color swatch. And then have it like that. But one of the things that I wanted to show you guys with the idea of like introducing or inputting the different geometry within an order is that then we can use that order to extract that geometry. So if I analyze what's happening with the attributes, is that you will find that is a list of lists, meaning that I have a list of information. So all of this here is one pod. And then the other one, so this is 0, 0, right? So this is one pod, then this one is another pod, and so on. So what I can do is that I know that this first one, right, is my frame. And then I know that the second one is my body because that's how I input it. And then I know that all these other guys are my glazing. So then I can use that to be able to isolate this geometry separately and be able to, again, bake it. So bring the geometry back into Rhino separately in separate layers so that then when I'm rendering, I can start assigning different materials to it. So let's do that. This is not going to take that long, but I think it's very helpful. So what you guys can do is, since Grasshopper works in lists, what I can do is do list item. So this means that I'm going to input my list of lists, and then I'm going to say, get the first element. So now, what are we previewing? We're only previewing the frames. Sorry. So now we're only previewing the frame. So this is great because then this means that I can say, for example, custom preview. And then I can do swatch. And then I can, set up a different color. And those are my frames. So now I can preview this one. So now I'm going to copy, paste, because now rather than getting the index 0, that was my frame, because again, Grasshopper starts counting from 0. Now I want the second one, which is actually number 1 in the list that I know that is the body. So now, as you guys can see, right, the body just has, it's just kind of like the unit without the glazing. So again, I can choose a different color to display it. And then finally, I want the glazing. But what happens with the glazing is that I don't want to have to write 1, 2, or like 2, 3, 4, 0. No, sorry. I don't want to write the numbers from 2 all the way until 12. So what I want to do is actually do the inverse. So I'm going to use another component that is called index. So this one is working slightly different than the list item. So in this case, what we're telling this component, or what this component is doing, is that it's getting a list. And then what we're going to tell it is, I don't want certain items from this list. So I'm going to get a panel, right click, do multi-line, and then I'm going to say, I don't want the frame that I know is in 0, and I also don't want the body, which I know that is in 1. So once I have that set up, then the next thing that I'm going to do is input that into my call. So now the only things that I'm previewing here are the glazing. So now the glazing, I can set it up as a different or slightly different color. So maybe those colors don't go well together, but yeah. Anyway, so now the advantage is that we're not using that much computing power, because it's using the box collider to kind of like make sure that there's no geometry overlapping with one geometry. But then we're able to like output very smooth geometries, and then we're able to extrapolate from that geometry different parts if the geometry has them. So mullions, glazings, whatever you guys want. So here what I can do is also unpreview this. So now what I'm previewing right here is the detailed geometry from pod A. So what I'm going to do is move this a little bit further, and then I'm going to copy paste this entire thing down here, so that now what I can do is preview not pod A, but now we want to preview pod B. So what we need to do is here, where we had name of the part as in the filter, we want to make sure that we're filtering pod B. And then this goes orange because it can find pod A detail. So we need to make sure that we are now connecting the pod B detail. And I didn't connect it, sorry. Okay, so now I should see the slightly different pod that doesn't have all the 4 sides exactly equal, but now it has, let's say, more glazing on one of the sides. So now I'm outputting, or I'm like previewing also with a lot of like detail pod B. So the cool thing here is that pod B, right, could have slightly different graphics. So let's make it a little bit, right, maybe not that different, but yeah. So now I can see a little bit more clearly my two different units. So now the only thing that I'm missing is my my bridge. So now what I'm going to do is copy paste this entire thing again, and we are going to connect the bridge here. And then we are going to connect our bridge detail too. But now in this case, what happens is that we don't actually need all this just because we don't have multiple geometries for our bridge. So we can keep it kind of like simple. But we can see here that if we go back to like our basic, right, it goes back to being like that box that actually doesn't connect to one another. But when I say that detailed geometry, we can see that is using some of like those openings as potential, let's call them doors. Okay, great. So now we have that. Another thing that you guys could do is that we could just use one, so that we can go quickly from, let's say, 1 to 10. So let's say 10. So now we have that. Another thing that you guys could do is that we could just use one, so that we can go quickly from, let's say, 1 to 10. So now we have that. Another thing that you guys could do is that we could just use one, so that we can go quickly from, basic to detail. So now if I go to basic, the entire system should go to basic, but it's because then you need to be able to unpreview this. It's because this one is not generated from the other one. We need to unpreview that, and then you would have to like preview this, guys. So here we can change a little bit the colors. Not that it helps so much, but you guys can get the idea. So if I go back to detail connection again, so there are those two ways to like preview it. So you can like use this, you know, if you want to go a little bit into like more detail or not. Okay, so the next thing that we could do is that now we have our entire system set up. So I'm going to, so let's start adding some constraints to this geometry. So one of the things that are happening is, if we see this, is that my aggregation is it's growing on both ways. It's going up and down. So if you guys wanted to set, let's say, a ground plane or a ground floor or something at some level that is very specific, what we could do is set up like a plane constraint that could tell this geometry, I don't want you to like build above or below this kind of like setup, this kind of like constraint. So let's do that. So what I'm going to do, I think this is fine. Make sure that this is a little bit small since we're carrying a lot of stuff, but what I'm going to do is, I'm trying to avoid copy pasting the bifocals. I'm going to copy paste this entire thing and then move it down. And then what I'm going to do is just, you guys don't have to do this. It's just because of like the bifocals. I'm going to disable that. So we should all be somewhat here where we have like the 3 units. We're able to preview them. We're controlling kind of like our rules. And then the next thing that we want to do is we want to set up a plane so that the aggregation maybe doesn't happen below a level that we don't want, for example. Okay, so let's start working towards that. Just going to, I want to clean this a little bit. So one of the things that you can do for all the IDs is that rather than showing the wire display, you guys can go to hidden. So this will like create a little bit of like almost a radio or Wi-Fi signal. So it's still connected. It's just not being displayed. It's just so that this can be a little bit cleaner. Again, you guys don't have to do it, but I just think that right now, for the sake of like keeping this a little bit cleaner and you guys not seeing a bunch of wires going back and forth. Okay, so the plane constraint is something that we can like input into our stochastic aggregation. So where you guys see GC is where we can start inputting what are called global constraints to the system. So global constraints can work in many different ways. So we're going to kind of like see a couple in this exercise so that you guys can start getting an idea of how to start giving a little bit or start having a little bit more control as to like how your aggregation is being distributed. So what we're going to do is we're going to create a very simple plane. So that's how we're going to start. So I'm going to create a plane surface. So that plane surface should be somewhere around that center point that we can see it right now. So what I'm going to do here is that I'm going to do domain. So I'm going to construct domain. The reason for this is because I want to give very specific or give specific boundaries to that plane. So I want to make sure that it goes from from negative 200 to like positive 200. So that's why I'm like creating the domain. You guys can also draw a plane in Rhino. I'm just showing you guys another way to do it. Here you guys can go, can zoom in into the A input and then go to expression. So in expression, we can type minus X, meaning that whatever the value that I'm giving to this input as A is going to turn negative. So now what I'm going to do is give this to X and give this to Y. So now I'm creating kind of like a huge plane that is kind of like in the 0 level. So you guys can like move it up and down, but I just want to get the point across. So so we have like now our plane that we want to work with. And now this plane, somehow we need to like connect it into our general constraint. So what we can do is go to aggregation, and then you guys will see that we have like plane constraint and then also mesh constraint. So don't worry, we're going to get to mesh constraint in a minute, but let's start with plane constraint. So what we're going to do here is that this component, plane constraint, that is again in aggregation, what is taken, it has 3 different inputs. So the first input that it has is that it's asking us for a plane. So we're going to give it this plane. The second thing that it's asking us is whether or not like is set true by default, and it's like telling us about like the positive or negative direction of like the z-axis. So what I'm going to do is I'm going to create a Boolean toggle because it either takes true or false. So I'm going to set it up here so that then you guys can remember that that's something that you guys can change. So soft means that whether or not you want the system to be super strict. So soft means that there's some level of tolerance, right, below this plane constraint, where you are allowing certain like leftover, let's say, geometry of your aggregation to happen. Meaning that I'm going to actually zoom in. Meaning that, give me one sec. Meaning that if that's, let's say, our plane constraint, right? And then I have a bunch of like geometries, let's say, that are aggregating at the top. Wasp is like, this is fine. But that's soft. What is asking you is what happens if, you know, the connection is somewhere here. So that means that there's a little bit of that geometry that is forming below your plane, but it's because it's starting, like the connection is starting up here. So here is asking you, oh, should we still consider this as a geometry, or should we just not consider it? So this is what the soft input is telling you, whether or not there's a little bit of like leniency that you want in your system, or if you want no leniency, meaning that we shouldn't have anything beyond this plane. So I'm going to allow for some leniency, meaning that I can set true to soft, which is also true by default. So once we have those, once we have our plane that is connected into our plane constraint, what we can do is come into our global constraints and connect it to that. So once we do that, you guys are going to see that still nothing happens. It's like not obeying the plane at all. And it's because what we need to do is that we need to tell our aggregation, we need to like make it aware that now we have a plane constraint. So within mode, right now what happens is that it has different setups. So it has like 0, no constraints, which is what we have been working on. It has local constraints. So the local constraints are mostly coming from constraints that you guys are going to like have within your actual parts. But global constraints are the constraints that we have actually here as our plane constraint. So what we want to do is that we want to make sure that we have our mode set to 2. So what I'm going to do here is you guys can plug a slider or a panel, but now I'm going to set it to 2. So now what happens? So now what happens is what I was telling you guys about. There's a little bit of leniency, but in general, like the aggregation is happening above my plane. So what happens is that if I change this to false, now it's an actual hard, kind of like hard boundary, meaning that the aggregation is not anywhere below that plane constraint that I set up. So again, guys, it's up to you how you guys wanna, start setting. At some point, it may, even though if it's on true, it may not do that all the time. It depends on where it's starting. So what's happening here, just so that you guys know, is that the bridge, so let me see. You guys don't have to do this. I just want to explain something. So what happens here is that the bridge is right now on the 0 level, and where it's connecting, right, it's significantly higher. So remember that chance, right, of like the stochastic aggregation. So now we have 3 units. So there's like 33.333 chance that it will select each of like the units. So whenever it selects the bridge, it selects the bridge and it forces, right? This bridge is forcing the pod to actually, go below the plane. So this is why, at some of like the reset iterations, we have that condition that the units are below the plane, and it's not happening at all the times. The other thing too is that, or that maybe some of you guys are wondering, is that yes, I could, either bring the bridge up, and then I could control these connections, right? So I could split the up and down, similar to like how we did the other one with the mid and back. I could split the up and down so that it just aggregates upwards and it doesn't aggregate downwards. So that's another thing that you guys, could consider. Meaning that in this case, there are like a little bit of like different ways to do this. Okay, so now I have my my plane constraint. I can like leave it to soft, and there you guys have it. So then the next thing that I want to do is I want to set up mesh constraints. So the idea for mesh constraints is that you are either using them for elements to like be within that kind of like imaginary boundary that you guys are creating, or you guys can use it to like break up some of like that geometry. So in the Rhino file that you guys have are 2 different conditions. So, or 2 different set of constraints. I'm going to turn this off for the time being. You guys have constraints out and then constraints in. So we're going to look at the constraints in for a minute. So what we're going to do is let's first work with one. So what I'm going to do is I'm going to bring in a geometry. So I'm just going to bring one of them for 1 sec. If you want to bring both of them, that's fine. I was planning to do that in the next one, but we just need to make sure that we're joining them. That's all. So just keep that in mind if you are going for both of them. Okay, so I'm just going to like hide that. So what I'm going to tell the system is that I want these units to be rearranged within this shape. So to do that, I have inputted the geometry that I want to keep. And then the next thing that I want to do is bring in my mesh constraint. So within my mesh constraint, there are a couple of things that it's asking me. So one of them is the geometry. And then it's also asking me whether or not I want this to work as, like I was mentioning, to create kind of like where you're putting in all the geometry, or to use it to avoid, to kind of like create openings in your aggregation. So what I'm going to do is I'm going to set up both of them to true for right now, and then we can see what happens. And then right now what I'm going to do is just connect this one, and then nothing is happening. So let's see what happens. So what's happening is that it's telling me that it could not place 122 parts. So what's happening is that the mesh that I have selected, the geometry, sorry, my units are not within the geometry. So that makes it hard, or well, that makes it impossible right now for it to like build any geometry. So if I go to Ghosted, we'll see that all of my geometries are really within this other block. So what I'm going to do is actually reference this other block, since that one seems to, since this one is the one that seems to be able to work. Okay, great. So again, this one is working because within this mesh is where we actually had our geometry. So now we can see that we can start growing our geometry, but then you guys will realize that there's a point where the aggregation is going to shoot out an error saying, I can only place up to so many parts, right? So it's saying I cannot place 136 parts because it doesn't have anywhere else to go. And right now what I'm doing too is that I'm telling that this this mesh constraint is actually like a soft constraint. So we can see that some parts of the geometry are actually coming out of that mesh constraint. And it's because here in soft, I had it as true, but now what happens if I have set it to false? So you guys will see that I think I'm going to be able to place even less geometries. Yeah, so now I can place even less geometries because I have less space, right, to start aggregating those geometries. So in some cases, I can see that there's no way for me to like start aggregating. And this is because depending on where it's starting. So for example, if it's starting on the bridge, right, and we have like the plane constraint and this other constraints, it is actually not able to produce anything. Okay, so now we have right around the same number that cannot place. So I'm going to like lower this a little bit, and then what I'm going to do is bring the other, mesh, and then I'm going to do a quick solid union so that we can work with both of them. Okay, so I have one geometry, and then I'm going to quickly reference the other one. I'm going to do solid union. And then to be able to connect this geometry into the solid union, what I need to do is make sure that you guys have the plus sign. Oh, sorry, not the plus sign. You're holding shift and you're seeing like the little plus sign into like the wire so that you can like set more than one wire into an input. So now I'm passing that solid union into the mesh constraints. And now we can preview this, guys. Now what we'll see is that it's trying to populate the entire mesh constraint. So now it actually needs a few more. So now, yeah, okay. So what I'm going to do is preview this one. Great. So now we can see how our system, right, starts working into this. So you could start like creating some like pretty interesting aggregations with like all different types of mesh. So it could be like a super organic mesh. It can be like a more rigid one, like the one that we're seeing. Is completely up to you. And then, you know, this is very, you can create a lot of like different aggregations like this. So the other one that I want to show you guys is actually constraints out, and then to see how we can start merging both of them. So what I'm going to do is I'm going to get constraints out, and then I'm also going to input this geometry. So maybe we'll do just one for the sake of time, but I'm going to pick the larger one and then say set one geometry. Great. And then what I'm going to do is I can copy this. And then I'm going to do the geometry right here. And then I'm going to, in this case, say false right here. And then I'm going to allow it to be like a soft condition. But this means then that rather than conforming into like this space, what is going to happen is that it's going to create a void right there. So what I want to do now is to merge. So I'm going to merge both of my constraints. I'm going to delete the third input, and then I'm going to put this into my global constraints. So I'm also going to hide the geometry everywhere so that I can see what happens. So that doesn't want to build that. Great. So now it's building it. So now what we're seeing is, right, that opening within our aggregation. So maybe we're allowed to like input a few more, but maybe not. So you can like start inputting like many more constraints. So I had the other one, so you guys can just like copy paste, you know, and then you guys just add another port here at the merge. And this is allowing you guys to kind of like create openings or like, you know, in your aggregation. So you can like set it up anywhere you want. I would just say try to like keep them clean. So I would like have each one a little bit separate so that then if you guys want to delete one, you guys don't have to like reference or unreference everything else. Okay, so this is kind of like this exercise, and I think that we're really we're supposed to be almost done, but I wanted to show a few more things. So I think, okay. I think I'm just going to jump into the next exercise, Mike, unless you want to go through some more Q&A.
Yeah, it's Pavlina. Hi, guys. Yeah, like if you want to like answer some of the Q&As for this part, like you can go ahead, or, you know, like continue with the next exercise. That's up to you.
Okay, cool. So I'll just try to like get through like a few questions, and then we'll jump into like the next exercise. And then I think that the last one I won't build it from scratch, but I'll just take you guys through it because it's almost 2 and I don't think we're not going to make it. So why do you guys need a Wasp attribute? So it's just to like store more detailed geometry. So it's really not not a requirement. It's just that if you guys have like a super detailed geometry that is probably, you know, a little bit heavier, then it's going to take longer to compute than having like a more simpler geometry, like a box that is computing the information. So the bridge detail is just like a geometry. So it's a detailed geometry for that unit. So I'm sorry I missed what to do with that diagonal green line inside the detail. What do we do? So all the lines that are inside the geometries, what you guys are using it is to like create your connections. So you guys are just using them as either point or curves to set up your parts. Okay, so what is the Wasp plane constraint? So the Wasp plane constraint, it allows you to input. So what I'm going to do now is kind of like, so what it allows you to do is to like set up a plane anywhere that you want or however you want, so that instead of like the geometry kind of like aggregating up or down, it just aggregates above that plane. So so it's to like start controlling the aggregation or giving you a couple of more tools as to like to get a little bit of like the aggregation that you guys are looking for, if that makes sense. Where is the detailed geometry made? I made it in Maya. You guys can do it wherever you guys want. It's more like something that, you know, has a lot of like faces, or it's a little bit more complex. So it makes it, like I said, again, it just takes much longer to compute. You can make whatever dimensions you want for both the constraints, for the geometry. The reason that we're giving you guys these files is so that we can like focus a little bit more on Wasp than actual modeling. So yeah, this is completely free. I'm just kind of like giving you the run through of like how the plugin works so that you guys can work with whatever geometry you want. You can like create it in Grasshopper, you can create it in Maya, you can like bring it from different softwares. It can be super simple like a box, or it can be like highly detailed. It's like completely up to you guys. No, we don't have time. So we are already 10 minutes before 2 p.m. and I want to show you guys 2 other exercises. So we're not going to get to the Maya part. The Maya part was mostly covered in Alejandro in the first 2 webinars. Yeah, you can like use the plugin or an attractor function to like change the aggregation geometry. Yes, of course, you can like do so many different things. You can even use like millipede to like create a very specific field system. Like there are so many ways that you can start plugging in a lot of information. You can like use Kangaroo to start, you know, relaxing meshes to like use them as constraints. There's a million things that you guys can do. Okay, so I'm going to stop sharing for a minute, and then we are going to move into the next exercise. So I'm going to try and like go a little bit faster, and I think that the last exercise is going to, I'm just going to like go over it very quickly because we are pretty much out of time. Okay. So if everybody, yeah, I know that there are 6 exercises. That's what I'm saying. The next one we'll go over, but then the last one, I'll just, I won't start from scratch. I won't go over it with you guys. Yeah, exactly. We'll just skim through it. So don't worry about it. We'll go over it, but not maybe in detail as we're going with this ones. Okay. So everybody, please open exercise 5. Okay, and then just because we're out of time, guys, what I'm going to do is just I'm not going to build these ones from scratch. I'm just going to like take you through the different exercises, just so that we can also have a few moments for questions. So this exercise is also set up very similar to like how the other ones are set up. So you guys have your units. You guys have the center points, right? For like starting to like think about where you guys want your connections. And then you guys have also the lines to indicate the direction for those connections. So what we are doing in this first exercise that I'm going to like bring up right now is that we're just using the first unit. So here, what we're doing is that we are, and then I'm going to walk you guys through this. That's what I'm going to do. So we are connecting the geometry, and then we are also connecting all the points. So in this case, what we're doing is that we're just mapping all the points as like one big list. Okay. And then we're also mapping all the different curves as one big list, following, right, the same order that we did for the units. So once we have that, what we're doing is we're creating a very simple kind of like rule text. So we're going kind of like back to one of like the earlier exercises where we're starting to like map what connections we want to one another. So for instance, here we're connecting 0 and 1 that are both of the extreme faces. We're connecting 2 and 3. 2 and 3 are the sides. So we're connecting, oh, I'm trying to, sorry, I forgot to share the screen. Give me 1 sec, guys. Sorry. It's hard for me to like see your chat while I'm presenting. Okay, so now I'm hoping that everybody can see the screen. So let me start all over again. I'm sorry about that. So within this exercise, you guys should see 2 geometries. So the first exercise 5.1, what it does is that we're working with this unit, the one that kind of like has a little bit of like an L shape. So what I'm going to do here is I'm going to preview this geometry, and then I'm going to walk you through this part. So what we're doing is that we're connecting, we're linking our geometry, we're linking up all of our points into like one big list, and then we're following with the curves. So when you guys are starting to link so many different connections, just make sure that you guys follow the order as it is, because if not, it's going to create problems. You guys will probably get this in red. So the next thing that we're doing is we're creating like the aggregation setup. So in this case, similar to like how we did with exercise 2, what we're doing is that we're specifying exactly what the connections that we want to do. So in this case, what we're doing is that 0 and 1 are the kind of like outer sides. So we're saying, okay, connect this 0 to that 1. The other one that we're doing is we're grabbing 2 and 3 so that they can connect to one another. So if you can imagine, it's almost like another, right, of the shapes. We're telling them to go right there. So that's what we're saying with that rule. The next one is 4, 5. So 4, 5 is a little bit more straightforward. 4, 5, we're telling it to connect top and bottom in a very rectilinear kind of like stacking way. The interesting thing here to note is 6 and 7. So 6 and 7 are slightly off center, and then 6 is straight, and then 7 is not. So if you guys see 7 right here, it's a little bit different. So that is going to start forcing a little bit of like a jog between this aggregation that we're going to see in a minute. So in here, what I'm doing is just telling, 5 is always going to get connected. And I'm just noting this so that you guys know that 5 is always going to get connected to 4. So that means that when I show you guys this aggregation, you guys are going to note that we are always aggregating downwards, because I'm like always doing that as a constraint as part of like the rules. So again, like I've been saying the entire webinar, the rules become really important for the type of like output that you guys want to start setting up. Okay, so that's one thing. So now I'm going to unpreview that, and then we're going to go into this next part. So in this next part, what I want to show you guys is that there are some like really interesting tools that allows us to not always start the aggregation wherever we have drawn our geometry. So as you guys know, the stochastic aggregation chooses between the different units that we have or that we're working with. So there's always like, if you have 2, there's a 50-50% chance. If there are 3, there are like 33.333% chance, and so on. So the idea here is that we can maybe move some of these geometries or copy some of these geometries to start aggregating from different locations. So this becomes really useful if, let's say, you are aggregating in different like blocks, right? You have kind of like a side boundary that allows you to like, let's say, build on like very specific things, or you want to leave some spots open, or whatever is the case. This tool allows you to transform the initial tool and set it as a preliminary setup for your aggregation. So the way to do that is that right now, as you guys can see, we'll still have our same aggregation. So it's still working. But what I have done up here is that I have created a transformation setup. So the transformation setup is what is allowing us to like really move our geometry. So this can be found in the transform part. So within the parts tab, you guys can go to transform part. And then what happens is that you're going to get this component right here that is going to take in a part. So this is going to take our unit setup that we already have, and then it's going to take a vector or a transformation. So for instance, if I were, let's say, want to like transform, sorry, I need to input that here, to move our geometry a little bit to the side and then hit my restart button, then now what happens is that my geometry no longer starts here, But now because I have given it a new location, because I'm transforming it, I'm like moving it here in the x-axis by 250. So that means that now my aggregation here in preview, it has a new starting point, which is right here. So now one of the cool things that we can start doing with that is that we can start creating a series of different starting port locations like I was mentioning. So now rather than having this one location, now I can have two starting locations. So now if I were to like hit start to that one and give it a second, sorry, it's computing. So now we can see that our geometry or our aggregation is not just starting from like the one spot, but it's starting from two spots. So finally, another thing that you guys can do is to actually start creating your own vectors as well. So I'm just showing you different ways. So here it's just like moving along the X. You guys can type up using a panel your different locations, or you can create vectors using sliders so that then you have a little bit of control as to like whether or not maybe you want to like lift them a little bit higher. And then you guys can start moving them around as you please to start setting them up maybe in plan in the location that you guys want. And then you guys can have, like in this case, I made the z-axis all the way 500 so that you can see that in this way, what I can do is that I can force the aggregation to start up here. Not necessarily just to like start in the 0 axis, but to start up here so that then it can aggregate down. So now what I'm going to do is I have connected this vector. So now I'm going to hit reset. And now what's happening is that now my aggregation is starting all the way up here. So this allows you, again, you know, a great tool to start creating a lot of like different variations within within your aggregation. And then I'm pretty much using the same setup that I showed you guys. It's just that we are kind of like including these transformations. So that's that. Another thing that you guys could do too is that rather than the transformation be moved, you can like have a transformation that is rotate. So you guys could connect that as well. So you could like start rotating some of this geometries down so that in concept you could have one aggregation that starts like this and then another one that starts intersecting or, you know, going in different directions. Okay, so I'm going to freeze that, and then we're going to keep moving. Okay, so here what I'm doing is exactly the same setup with a transformation. The only thing is that now I'm adding that second geometry that looks a little bit like that. So we already know how to do this. And then what I'm doing here is that I'm just extracting the geometries out, right, by doing that filter that we also know already how to do. So this is, again, creating like a little bit of like a different setup aggregation. And then what I'm doing over here is that I'm starting to like incorporate, right, the connections between my first part and the second part so that when I hit reset, they can both be working back and forth. Great. So that's that. Then the other cool thing that we're going to see in the next exercise is what happens when we start looking at field aggregations. So this one is going to take a little bit to display. So just give it a second. Okay, perfect. So let me take you here step by step. So give me 1 second. So what we're used to doing is that we, give me 1 sec. I'm like rebuilding the stochastic aggregation. Okay, so what I have here is that we have moved, right? Our, that we had moved our how am I calling them? Our units in different locations. But rather than in this case using a stochastic aggregation, what I want to do now is use a field aggregation. So a field-driven aggregation just works a little bit different because now what we're doing is that we're providing a field to the system. So a field is, I'll show you guys in a minute, but the cool thing is that, again, we're just like giving another level of control to what we can do with our aggregation. So I'm going to turn this on and then take you step by step through it. I'm going to turn this guy off and then we'll go through it. So a field aggregation kind of like has the same or very similar inputs as the stochastic aggregation. So one of the main difference here is that you guys can input a field as a list that we'll look in a minute. So here what I'm going to do is maybe reduce this number for a little bit so that just not so large. Okay. So what the big difference with this two is that this is allowing for a field aggregation. So what we're going to do here is that this is our field setup. So the way that we're showing this example is with a curve field. So we're going to like go through it. So what I have done in the Rhino file is that you guys have a curve. Okay, so this curve, what it's doing is that it's going to act as a little bit as an attractor in terms of like telling the aggregation, I want you to like do the aggregation, but around this curve to see what happens. So that's what we're telling the system. So what the fields is going to create is that it's going to like map out this, this curve having like a bounding box so that it can evaluate all the different points in space for this curve and compare it against where we can place our geometry. So I'll say that again. So we have our curve where we want to start mapping our different geometry. So what we want to do is that we want to have that curve, and then what we are going to have to do is create a box around it. Why do we need to create a box around it? Because the fields points that you guys can find here, Wasp field points, is asking for like an overall boundary. So this boundary can be given as like the bounding box where the curve is contained. So what it's doing right here is that is kind of like mapping every, it's dividing the box into like a resolution that we're setting here. So the higher the resolution, the more points that you're going to get. So what the fields are doing is kind of like creating a lot of like small boxes within our larger box. And the idea for this is that it's almost like when you guys zoom in a lot into like a Photoshop JPEG image, right? The photos actually comprise of like tiny little squares that are called pixels. So the idea here is that rather than having a square in 2D, what we're having is that we're having a box. So an object that is in 3D. So that's how we're getting the resolution to this box. So the more smaller boxes you guys have, the better the resolution. But the more boxes you guys have, the more computing power you need. So there needs to be like a little bit of like a fine line in terms of like how many or how much resolution versus versus, you know, the computing power, so that you guys can like get to like a kind of like a cool in between. So what then we're doing with these fields is that we're using our curve as a point attractor within this field, so that, and this is where I show you guys this, so that we can start mapping, in this case in red, where our curve is. So wherever is like closer to red is where we want, right, our geometry to be. So we are pretty much telling it that our geometry should be somewhere within that kind of like yellow-red boundary. So this is a very, very common kind of like attractor setup that you guys can find. So it's pretty much taking the overall points in the field, and then what it's doing is that it's computing it, or it's mapping the distance against my curve. So if I preview this for a second, what it's doing is that wherever I have these points, it's pretty much calculating the distance between the points in my curve at all points, so that it can like understand how close it is to it, so that it can understand where and where it can't place geometries. So the idea is that once you guys have this field kind of like set up, we can plug it into where it says field in our field aggregation. So everything related to here, you guys can find it within the aggregation. So Wasp field driven aggregation, then you guys have your Wasp field points. That is the one that we just looked at. So here you have everything. And then the other thing that I'm using is that I'm using that curve right here, so that I can extrapolate from that curve specific points in that curve, so that I can like then drive my initial geometry there. So what I'm doing is kind of like, you know, I'm moving my unit along that curve, so that you guys don't have to do this, but I just thought that it would be kind of like cool to like, you know, have the starting points at the actual curve locations. So then when I'm running my aggregation, so pretty much exactly the same that we're doing with our stochastic aggregation, we're doing with the field aggregation, meaning that we still need to like output our geometry. We're still using the kind of like filter that we have been using. So we have to connect it back to like our unit names. So that's exactly the same. And then we're creating two different custom previews. So what you guys are going to see here is that I'm having like three different kind of like aggregation clusters, right? So you guys can see here 1, 2, and 3 that are originating from different locations that I have set in my curve. So this is something that you guys can do in many different ways. So you guys can like have a closed curve. You guys can like expand it a little bit more. Here, you guys can start, you know, creating or adding more kind of like units to the system. So give it a second there, because it may take a while since I'm also streaming. So you guys will see that as we're adding more and more units, what's happening is that it's actually following the curvature. So now we can see that it pretty much takes over the curve. So for fields, you guys can also set up different things. I set up the curve because you guys need a little bit, because we could do this kind of like setup by moving by transforming some of like the original unit locations. But one of the things that you could do as well is use a geometry. So that could also work for a field aggregation. And that could be either, you know, kind of like a wavy plane or something like that. But this would be your actual setup, working with field aggregations, and again, your field kind of like input. So what I'm going to do now is I'm going to stop sharing so that then I can jump into the other into the last exercise. So I'm opening it. Give me one sec. This one is a little bit heavier. And then okay, so I'm setting up this, and then okay, so now we have kind of like our final exercise. So in this setup, you guys will see a couple of like different things. So this is working very similar in terms of having a more abstracted, simpler geometry that we're going to use to pass through the aggregation. And then what we're going to use is a couple of like pufferfish components to actually then transform this geometry into like some more detailed units. So in here, what we have is that you guys are going to see the aggregate or the aggregation here. So that has a couple of things. That has the actual geometry that we're seeing. Sorry, give me one sec. Sorry, I'm losing my voice a little. Okay, so within the layers, you're going to see the geometry that is helping, again, that is a more abstracted version. Then you guys have the direction, which are the lines as to like how we are setting up our connections. And then finally, we have our center points. Then the next thing that you guys are going to have is, if I just preview the aggregation units, or like the more abstracted geometry, here's where you guys are actually going to get the detail units that were part of like one of the original renderings. So here there are like different like unit setups. So I believe there are 4 right now. So we have one with the stairs, And then we just have another one that has a little bit of like the openings extruded outwards. So what we are going to start doing is, if we focus on exercise 6.1, we do the same thing that we have been doing all along. So we set up our geometry, we set up our points, we set them up in an order that we understand. So in this case, what I'm doing is back, front, top, bottom, and then side, side. So very simple. Why am I doing this? So that I can create a very simple logic as to like how they are aggregating. So if you notice, the way that this geometry was designed was so that when we started aggregating this set of geometries, we could start creating a little bit of like a radial aggregation. Just because I'm asking, or I'm going to ask here for 4 and 5 to connect to one another. So here, as one of my rules, you guys can see how I'm connecting 4 and 5 together. So again, this is forcing, right, my aggregation to start creating a geometry that starts, right, aggregating in this manner. Apologies for the bathroom, but I think that you understand the point. So this is kind of like one rule that I'm setting over here. So I'm going to zoom in here. So first rule, right, that I have here, I'm creating like the side kind of like connections 4 and 5. The next kind of like rule that I have, and please note this, is that I'm telling the geometry to actually rotate within itself. Why? Because the first one that I'm saying is 0 to 0, which means that this geometry now needs to get mirrored, because now this 0 needs to be connected to the other 0. But this is a pretty symmetrical shape, so you guys won't see the difference. But this affects, because now the way that I'm starting to set this up is that the aggregation is forced to like be always inwards, meaning that the aggregation here is not fully forced to like go outwards. So as you guys can see as well, we're forcing this 0, right? This 1 to connect to this 0. So again, we're forcing like the geometries to start aggregating here, not so much outside. So this is going to start creating, again, another type of like aggregation. So I would advise you guys that, you know, if you start playing with some of like these different rules, you're going to start creating like very different outputs. And it's because, again, we're trying to like control how is it that we're connecting things to one another. And then finally, the one that we are not, or doesn't do anything really extraordinary, is the top and bottom, the 2 and 3, which we know that we're going to use it to like stack up and down. So that's how we're working with kind of like our connections, that we're merging them so that we can keep them a little bit isolated. And then we're using our rule text that we already know how to use with our stochastic aggregation. And then we're just seeing, right, that geometry and how it starts aggregating. So again, if you guys start changing some of like this outputs, especially this ones, you guys are going to see that then the geometry can start expanding more horizontally, because then you're not forcing it to stay so constrained. Okay, so that's kind of like part 1. So let's look at a different part right here. So in this part, what I'm doing is that I'm leaving this first condition. So everything that we have done here, pretty much we're copy pasting it. But the difference here is that if you guys notice in the legend here, is that we have 2 attractor points right here. And the only reason, or the reason why we're starting to like work with those attractor points is so that we can start mapping different units. So in this case, what we're doing is something that is a little bit different. So rather than relying on Wasp to create different units that have different details, right? Different like detail geometries. What I'm going to do is actually use other components to transform these geometries into the more detailed geometries, the model geometries that I just showed you a few minutes ago. So what I'm doing is that I'm using 2-point attractors at 2 kind of like extremes so that I can start mapping. So this is what I'm creating, different like domain values, so that I can start mapping and isolating 4 different geometries or 4 different types of that geometry without having to create 4 different units. So the way that the attractor logic works, again, is a very standard attractor logic. So we're using pull points where we're grabbing like the center area for every one of like these geometries, and then we're comparing it against that point. And based on that distance result, we are pretty much mapping those distances results that then they get evaluated within this parameter. So if, let's say, this geometry is within this parameter, then it turns red. But if this geometry is within this other parameter, then it goes to a different group that is green. So that's what we're doing here. We're using like the attractors to kind of like use the, to kind of like split that same geometry into like 4 different types based on their location from those attractor points. So once we're doing that, we are getting kind of like this preview to start thinking about the 4 different types. So I hope that you can guess where we're going next. That is that we are using those setups to start transforming those type of geometries into the detailed geometry. So what I did here is let me preview, or let me kind of like disable everything here except for this one. So what I'm doing here is that give me one sec, you got away. What I have done here is that I have referenced all the geometries that I had in Rhino back into Grasshopper. So similar to like how we keep constantly doing our geometry, what I have done here is just imported into Grasshopper, or reference into Grasshopper, our different geometries. So let's say that's unit type 1, that's unit type 2, and then this guy is unit type 3 with the stairs, and then finally our unit type 4. So what we're doing here is that we're putting all of those geometries into one list together, meaning that all of them are here in our list. So we have like 4 different types of mesh that then what we're doing is that we're cross-referencing those with our types that were color-coded. So that's how we're able to not use Wasp attribute, but actually use the transform tool to convert that geometry that we used as a collider, right? That initial geometry. And then we're able to transform it into the ones that are more detailed. So that's what we're doing there. And then in the final step, what we're going to do is, and this answers a few of your questions, some of like the modeling. So where did we stop? Okay, so let me take you guys through this. So now what we have, right, it's just that we just transform all of our geometries into our detailed geometries. So what we're doing is that now we're using a few of Weaverbird and Pufferfish components. So if you guys don't have those plugins, maybe you guys will get an error on the exercise, but you guys can go to Food for Rhino and download them. So some of like the rebuild mesh, for example, is from Pufferfish. So if I do that, you can see that that's from Pufferfish. Sorry guys. The other one is from Weaverbird that is pretty much working with meshes. So what we're going to do here is that I'm going to reduce, I think 120 is fine. So we should be able to take this. Okay, so we have all of our geometries at the moment. So what we're doing here is that we are rebuilding the mesh. So we had a very, we had our mesh that we exported into, and now what we're doing is rebuilding it. Why are we doing this? Just because we want to make sure that we don't have accidentally a little bit more vertices than we should have, or like some of them are deleted. Sometimes it's a good practice. And we're making sure that if some of the vertices are very, very close, or like one over the other one, that they are becoming welded. So the next thing that we're doing is that we're using like an algorithm that is the Hammett-Clark algorithm, that what it's doing, if I display the mesh edges, is pretty much subdividing the faces of the mesh so that it can like start to like smooth things a little bit more. Also, sorry. So this is this is splitting up into like quads, and then the Hammett-Clark is right here. So that one is splitting it one step forward so that it can start smoothing this geometry. So now we can see that the output is not as orthogonal as the one that we had, but now it's a little bit more organic. So one thing here that you guys can do is that you could bump up this to like level 3. I'm not going to do it right now just because it's going to take a lot of time to compute. Level 3, what it's doing is that if you guys have, let's say, a mesh face, one level is starting to create, let's say, one subdivision. So this is in terms of like what we were talking about with the pixel image, right? The more subdivisions that you have, the more resolution you get, but also the more computing power it takes. So just be mindful. Right now we're keeping it to level 1 because that's giving us like a good enough kind of like organic or smoothness to the geometry. But you could work with a higher one. So then the next thing that we're doing is this is how we're doing the columns that were kind of like extruded. So what we're doing is that we're selecting the bottom of the geometries. So the bottom of like our unit geometries. So let me see if I can like get it. Is left open, so we are selecting them. The reason why they look like a circle is because we have run the Hammett-Clark algorithm, meaning that we have subdivided this edge so that now it's a little bit more smooth. So now what we're doing here, is that we're creating a plane very low. Then we're projecting all those curves into that plane so that then we are pretty much telling, okay, this upper curve, I want you to loft it with a bottom curve. So that's how we're creating that's how we're creating the columns. And then we are connecting the geometry with the column to create one single geometry rather than two separate ones. Sorry. And then the other thing that we can do here is that we can start splitting some of these geometries so that we can have different previews. And then I believe that within your file, you also have a set of like, you know, high res aggregations that were baked. Yeah. So that's how we're getting, you know, the geometry. So you guys can start playing with more of like the units that are actually aggregating to one another. Just be mindful because this one is a little bit heavy. That's why I have it set right now to too low, because I don't want it to crash the computer, because then it kicks me out of Zoom and things like this. So main thing here is that we're doing kind of like the opposite that we did in one of like the previous exercises. So again, rather than setting up our detail with our attribute, our detailed geometry with our attribute, what we're doing is that we are using an attractor system to really create types of that geometry so that then we can like replace it with the detailed geometry that we have selected. And then this is just so that we can like build and extrude some of like those columns that were part of the design. And then finally, we're just kind of like randomly splitting, which is a similar component to what we did originally in exercise 1 in terms of like dispatch. So that's kind of like all the 6 exercises. Sorry, we had to like go like this for the final 2, but we're already 40 minutes over the webinar time. So I'm going to try and see where I stopped answering. So let me see.
Hey, Alan. Hi, everyone. Oh, yeah, you can maybe answer some of the questions for geometry that you already showed, and then maybe we can have like some, you know, like additional time with the guys, and if they want, they can maybe even raise their hand, and we can, you know, like have a couple of questions, live questions too.
Okay, yeah, I just think that I have 2 questions that are sorry, an answer in the Q&A, and then we can do the hand raise.
Perfect. Okay.
Okay, so it's asking, what is the transformation geometry script all about in purple in exercise 5.2? Okay, so the transformation geometry is what allows you, let me explain this here. So what happens is that when you guys create any aggregation, no matter if it's stochastic or field aggregation, what happens is that your aggregation will start where you guys have your geometry reference. So in this case, the aggregation starts right here. So what the transformation allows you to do is that it allows you to start the aggregation somewhere completely different. So that's in general what it's doing. It also allows you to like, you know, maybe rotate that geometry if you want to. It also allows you to like maybe copy paste the geometry so that there's no one starting point, but 2 starting points or 3 starting points. So that's a little bit of like the flexibility that the transform part gives you. So then where are my, what is a graph mapper? So a graph mapper is another kind of like component that what it does is it multiplies the numbers or like the input that you're given it against an equation. So when you go to like graph mapper, normally it has like sine, it has the Bezier curve. So it just allows you to kind of like set up different. So for instance, if you were to like multiply 5, you know, times the numbers in a sine wave, right? You would get numbers that go, let's say, above 5 and below 5. So it gives you, it pretty much multiplies that number with a given math equation that you give it. Thank you, Daniel. I hope that I'm pronouncing your name correctly. Of course, I'm like, I just always want to make sure that everything is like clear. I think it was best for us to stay longer at the beginning of the exercises because the core concepts that I want you to take away from this is that pretty much rules are the core of everything. So working with a different like rule setups is going to allow you to like create completely different possibilities. So definitely make sure that, you know, you revise all the different ways that you can do it. We pretty much cover all of them, and just have fun. This is a super fun plugin. I think that Andrea is like doing a super great job in terms of like kind of like setting up and continue to develop the plugin, which is amazing. So I would say, you know, definitely that's great. So the other, I think I have just one more question. Is it possible to allocate a specific position for each type of the base geometry on the aggregation? For example, where some constraints are true, use only geometry A, and where some constraints, let's say, yeah, you can like really start, especially with local constraints, you could start doing some of the things that you're mentioning. But definitely with transform, you can start moving or start the aggregation with different units at different locations. Is it possible to make design process more computational with add-ons like Galapagos? Do you know? And I don't know any example. The tricky thing with Galapagos is that you would need to like figure out exactly what you're optimizing. That would be my advice. So for instance, you can like do an aggregation that is, you know, one of like the setups or like it's kind of like working with solar radiation. I don't see why you couldn't do something like that. But then you need to like think about, again, what are your rules? What are your constraints? Or like, how is it that you're working through it? Yeah, you can like automate a lot. So you can like create like a Python script to like start automating your rules. Definitely. Yes, it's definitely, if you guys already have like the script to like do a topographic surface. So it's just a matter of like replacing the surface, the curve that we did on exercise 5 with a topographic surface. Sorry, Pavlina, I think that I ended up answering more questions through here. So I can stop sharing and then I don't know how you do the hands raise.
Yeah, well, we can see them in our Zoom call, but like the guys should be able to see like how to raise their hands. So basically I can allow you like to open the your camera and ask some additional questions, guys. If you have any, we're happy, you know, like to answer them.
let me know if you see something.
Yeah, no, I don't have anyone yet.
Yeah, they were asking a lot of questions through the Q&A, but I don't see any more. So I think we got them all.
Okay. Oh, that's good.
Well, thank you everybody for sticking for an extra 45 minutes. But I think, you know, some of these things sometimes take a little bit longer, but I hope that you get or you got a lot of information or everything out of this.
Perfect. Thank you so much, Alejandra. Like it's, you know, it's amazing. And guys, don't forget that this is a small glimpse of, you know, like the master's degree and, you know, like one of the chapters that is part of this master's program. So if you have any questions or you want to check it out, you know, like it's on our website. So thank you so much, Ale. Actually, Alejandra is going to be one of the tutors in the master's program. So, you know, like I hope that you enjoyed today. Thank you so much, everyone, for attending.
Thank you. Hope to see you guys around. Bye.
Bye-bye.